we're going to talk about almost first. I'll talk about one other thing first and then get to the thing. Okay. First wanted to tell you, I think I mentioned this last time, but in case any of you were not here then and are here now. Normally on Fridays I'm on the Birmingham campus, 7:45 to 11:45 at least, okay? A lot of days they're much later than 11:45. But tomorrow, not there at all. Nor will I be on this campus at all. I've got an infusion tomorrow, and I have to be at the Kirkland Clinic.
Any kind of excuse to get off the job.
Yeah, it's something like that. Okay.
You should have had your funeral up there.
Huh?
You should have had your funeral.
No. I'd missed class then.
Oh, yeah?
Oh, no. Terrible thought. Okay. Oh, I see. Okay. So, but anyway, I've got to be there for blood work around 7-ish and supposedly called in around 8-ish, but doubt it. And then they, have all the preps and preliminary stuff, and then they'll start sometime around 9 or so, and it'll go until probably 4 or so. So, out of the picture the whole day. So, and then even then, I'm not worth much after because they, give you Benadryl, and that knocks me out.
Oh yeah.
Okay. So anyway, not on campus at all tomorrow. Now, let's talk about Tuesday then. This is what Melville was suggesting. Okay, I did call yesterday, and they said the van was available, so I hope they penciled me in. I haven't been able, I was going to do it yesterday, but my computer downstairs won't load the file from the L drive. That's where they keep things. So I had to use this one, but Dr. Bryant was using this one, so I couldn't get it done. And I hope to, while y'all are taking your test, make the request today. So, anyway, we'll take care of that. I think we will have the van, so I can carry up to, I think it's 11 students. If the rest of you can get there, however you can get there, that would be great. And y'all could carpool and that kind of stuff. If you want to follow me, we'll be leaving here. Now, here's the deal. I don't get out of class before this until 12:15. So if I get out of class at 12:15 and book it over there as fast as I can, well, safely, I can easily make that in a half hour, okay? Sometimes less, but about a half hour is what I allow. Then I've got the paperwork of getting the van and that kind of stuff, and then booking it back here. Yeah, they should have gas in it. What's that? Okay. So I may not be, it depends on how long the paperwork takes. I may not be here right at 1:15 because I've only got an hour to get there and back in the paperwork, and that's going to be pushing it. So I can either come up here and meet you here, or we can meet out in front, wherever you think would be better.
What time is it going to start? What time is it going to start? What time, if you drive your own vehicle, what time is it going to start?
Okay, we are hoping to get there by 2.
2 o'clock.
Yeah.
See, I'd rather meet somewhere around here because you said it's at 7, right?
Yeah.
I don't want to get up there because that's a big campus to get lost and not be able to find you guys.
Okay.
Oh, no, we'll find you.
Okay.
No.
I can tell you pretty easily how to get to this planetarium and even where to get the parking. Okay, but so if some of you want to drive straight from wherever you are coming from to Sanford, you can do that. You don't have to wait here in the classroom or anything else. What I was asking those people who are going to ride, you want to meet me up here or meet me down front? Where would you like to meet?
In the front? Up here.
Up here. Okay.
Yeah, I'm cool with it.
Okay, let me get Anthony marked
Yeah, they're
here.
going to leave at 1:15. So. You going to tell this?
We're not going to leave at 1:15, right?
Well, I hope to, but I can't swear that I'll be back by 1:15. Okay? So, let's meet up here in the classroom. Is that what I heard? As soon as I get back, or 1:15, whichever is earlier. Okay, or later. Okay. What's that?
You get in the van.
Yeah, I called yesterday and got it. She said yes, it's available.
I'll drive
Yeah. Okay. So,
What's the name of the building?
okay, it's the Christenberry Planetarium. Okay, and are y'all at least somewhat familiar with Sanford?
Yeah.
Okay. Okay, now there's at least two entrances to Sanford. Okay, there's two right next, there's the main big gate. You go in one side and out the other side. But a little bit further down Lake Shore, there's another entrance. Don't go to that entrance. Go to the big gate that, you go in one side, come out the other. Big building is, I think, the library or administration building. It sits on top of the hill. You can see it's real pretty campus, iron gate, brick, stuff. Turn in there. There's a light there, okay? There may be a light at the other one too, but that's the main gate. So go in there and go up to the first. It used to be a stop sign. I think they took that down, but it's the first cross street, and that's called Montague. Montegue, I think, or something like that. Montague. Take a right on Montague, okay? And Montague goes up and makes sort of a loop. In fact, it loops all the way around campus. So it goes up and makes a gentle left turn, but you're still on the same street. And then you'll get to one stop sign, which is just a pedestrian stop sign. Okay? And then just ahead of you, you'll see another. Now, that first one, you'll see a greenhouse on the right, and then a building, I think it's biology or botany or some sort of building, at that first stop sign. At the second stop sign, if you look carefully, you'll see a sign. That's the Christenberry Planetarium. So you have to stop. Again, it's just a pedestrian stop sign. It's not a cross street. So as soon as you go past the building, immediately down in the right, there's a parking area. It's not a huge parking area, but it is. If you see any spaces down there, go on down there and park. That's the closest thing to the planetarium. If, however, it looks like that's full, you can continue on up the hill, and as you go up the hill and you start around another bend, you'll see a parking deck. You may not see the deck. There is a parking deck to the right. There's a little parking area, first to the right, and then a two-level parking deck. You'll be going in the bottom level of that. I have never been there that there's not been at least a few slots available in that parking deck. So I've been there many times when that first lot right past the planetarium is completely full, especially in the middle of the day like this, okay? So look there. If there is a parking place, take it. If there's not, go on up the hill, and about the time you get to the top of the hill, you'll see a little parking area to the right and then a deck to the left. They've really camouflaged the deck so it's not that easy to see. It's not obvious, but it is there. You'll see it. And then park there. Now, if you can't park there, I think if you go to the next, you got back out onto the street, and then the very next one, you'll be on the top level of the deck. Okay? So I've never even had to go there, but I think that that's where that is. So then you have to walk back down the hill, and when you get that first crosswalk, the stop sign there, take a left, and you go down about 3 steps, and immediately to the left, that's the entrance to the planetarium. If you miss that, the next entrance is also to the planetarium. But it has a sign there, and go in there. And if you beat me there, more than likely Mr. Weigel is there. He's a young guy, really energetic, fired up about it, and he'll greet you and tell you where to sit and stuff. If any of you are driving and want to follow me there, you're welcome to do so. Like I said, I'll be leaving here as soon after 1:15 as I can. So if you're coming here to ride, be here in the classroom by 1:15 or as soon after that as possible. And please, if you are riding and you haven't let me know for sure, let someone else in the class know, and we'll wait a few minutes for you. But you see, it's going to take us the better part of 45 minutes to get over there. Okay, it's a nice little piece of real estate we have to cross. Okay, now I had hoped. Yes.
Which way are we going to take?
What's that?
We're going to take the interstate?
Most of the time I go Western Superhighway 150, Lake Shore, and go that way.
Okay,
that's pretty direct and not too many stoplights. Yeah. And Lake Shore usually moves pretty well right around Wildwood it might be a little congested. There's several lights there. But otherwise, you have to go the interstate all the way down, and then 65 and stuff. You go through Malfunction Junction. They're doing construction there. I'm a little worried about doing that one. So it might be a little faster, but then it might not. You know. So that's how I'm going to go. But you can go however you want to. Now, I had hoped to be able to call Jerry Tracy and see if when we could meet with him, because we're going to finish 23 today. I doubt if we could work it in for next time, but you know, to do the planetarium and go straight to Channel 13. I don't know if that would work anyway, but so the odds are, let's plan for Channel 13 to either be Thursday of next week, and let's see, is Tuesday of the following week our last day of class? Okay, because next week's the first week in October, and I'm pretty sure that the second week in October is when that's the last week of our first ministry.
Do we get like a fall break or anything? Is there a break
No,
between
it
the
just,
semesters?
no. The only break is Thanksgiving week. Okay, Cece decided to show up today.
My schedule says August the 21st through October the 13th.
13th.
Yeah, my schedule
Yeah,
says 13th.
and 13th is the second week. So that would be the Thursday of the second week. So that's going to be,
Is
okay.
anybody else in here taking him, picking up the next mini term?
Who? I mean,
Yes.
what's the next course?
I am.
What's that?
Well, maybe we'll all be here.
What's the next course?
After this one?
Yeah.
112.
Mine's still at 2 at Thursday.
What's
that
that?
class, he goes, what, like 3 to 8?
It's 3:15 to 7:45.
That's really sucks.
Huh?
That's what Can we get out early on Halloween?
Halloween. Goodness gracious, I'm not even
Look,
thinking
I've
about
been thinking
Halloween.
about this since I signed up for this class. I love Halloween.
The reason we have it later is the automotive students have to take Physical Science 112. And they've got their classes up until 2 o'clock. 3 o'clock. So to give them time to get over here is 3:15. So that's the only reason I put it back that far. Otherwise, I'd rather be out of here earlier too. Much. What's that?
Boogeyman might get us to this next time tonight.
I can't hear.
I said the boogeyman might
Oh,
get us.
I won't, yeah. Okay. Are there any other questions before we get going on today? So, the only options that we have then for the Channel 13 visit would be Thursday of next week or Tuesday of the following week. One or the other.
Send it up late.
Say again? Okay. All right. So let's talk a little more immediate if there are no more questions about the trip. Today we're in chapter 23, picking up with weather producers, which is 23.2. We should be able to finish the chapter today. The only lab for this chapter is the trip to Channel 13 Weather Center. So there's no paper lab for it.
I have a question.
Yes.
So if you don't go to the lab, you don't get a grade. I mean, to the planetarium, you don't get a grade for the lab.
Right. Well, okay, yeah. Now that's the deal. The field trips are technically optional. Okay, I can't force you to go on a field trip. I wouldn't think of it anyway. But if you go, you get a 25-point lab credit. Yeah. Okay? You get a lab. That means, whereas if someone doesn't go to either field trip, say, you still get to drop your lowest lab score. If you go to one field trip and get the 25 points, you get to drop 2 lowest lab scores. The one that you would have plus one more. If you go to both field trips, if we get to go to it, then you get to drop 3 of your lowest lab scores. So you get 25 points there. Yeah.
So how would you grade us if Jerry Tracy don't?
Okay. We just won't have a lab for that chapter.
So you don't count that?
No. It would just be.
So basically, okay, all of our labs are right?
Yeah, right.
Is there like a percent of our entire grade that the labs are worth?
The labs are a quarter of your grade. That's why I did 25.
Okay.
Then your tests, your paper, and your tests, I'll drop your lowest test score too. And that kind of stuff averaged together, including final exam, that's 75%. So whatever you get there, multiply by 0.75, and then add your lab average to it. And that's how you get your final grade. It's not a take-home, but it's almost easy enough to be a take-home.
Yeah.
Yeah.
Can I share something?
Yes.
It's college related, but it's not science related.
Okay.
I'm just really excited because I just met with my advisor,
Uh-huh.
my teacher, and I didn't do school good after the 8th grade. I failed. I ended up quitting school, going later in my 20s for my GED, and trying to go to another school. Trying to go to college again in my 30s. I'm almost 50 now, but this time I just found out today. I've been doing classes that are for my welding degree and for the robotics degree.
Mm-hmm.
It turns out, because I've been looking at both degrees all this time, that once I finish next term, I will get my welding degree, which I didn't even expect to get, but apparently I finished all the credits and didn't even know it. And the AUT degree, the robotics degree that I'll receive in August of next year, I will be holding 2 degrees.
Right.
Thank you. I'm so excited.
Yeah.
I just want to cry. But it's really cool. And if you have an opportunity, ask your advisors if any of your classes can go towards other degrees as well. Because that's what I've done is I've lined them up until I couldn't line them up anymore.
Yeah.
And then I didn't even know it. So
Yeah.
I didn't even know that was a thing.
Yeah.
Thank y'all.
And yeah. Now, that's in the career tech area. You can get certificates and you can get degrees. Both, and you can actually graduate several times. You can get a short certificate, long certificate, degree. Yeah, and the more you do, the better it is for the school too. It's better for you, better for the school.
So how about as an employer? How do they look at that you have 2 degrees like that?
I don't know. I'm not one. I would think the more the merrier, but I don't know that for sure. Chelsea's here.
It's fine, girl. Just stay here when you
She's gonna
Okay.
Thanks.
All right. Okay. Any other questions? Were there others about the yes?
So again, if we go to the planetarium and the weather station, you'll drop how many labs?
The 3 lowest. You get a 25 for each of the ones you go to, and then so everybody has the same number. Will be average. It's just people who haven't gone, you'll have just 1 drop. Go to 1, you'll have 2 drops. Go to both drops. If we get to go to Channel 13, we've had it sometimes when we just can't work it out with Jerry Tracy or anyone there. I hope we'll be able to this time, but sometimes they like everybody, they get short-staffed sometimes, and when they get into binds like this, he just doesn't have time. Yeah, but it is a fun thing, and he does a great job with it when we do go. So I hope we'll be able to get that, but we're down to the brass tacks. We only got 2 dates we can give him, and if he's available those dates, either of those dates, then we could probably go. So otherwise, if we don't get to go there, then if you go to the planetarium, you just get to drop the 2. Okay, good deal. Any other questions? All right, we were talking about what we've been so far in weather and climate. We talked about clouds and precipitation. That was the first topic. The second is the weather producers. The clouds get the moisture into the air. Precipitation is when it then falls out of the air. But what makes all that happen? Well, that's for the weather producers. Now, here's the idealized model. 23, yeah. The idealized model. Along the equator, that's where your highest temperatures are, right? Your most direct solar radiation. You get the most evaporation and stuff. So along that, 10 degrees north, 10 degrees south of the equator, receives more direct solar energy. You have more evaporation, the air heats up, and it rises. Now, because the air heats up and rises from the equator, you tend to have low pressure centers there. Okay? And guess where just about all the hurricanes and typhoons come from? Right near the equator, those low pressure areas. Okay? So it rises, and then when it rises, it spreads toward the poles because that's where the cooler air is. Okay? So the air cools and becomes more dense as it's rising, then sinks back, and guess where it sinks to? Latitudes around 30 north and 30 south. Where do we live? 33. Exactly. So in my other physical science class and also physics classes when I teach the mechanics, when we get to do one lab, part of the lab is determine what the barometric pressure is. And I usually, when I started this, I just always expected to be a little bit below, sea level. I mean, below normal atmospheric pressure because we're above sea level, stuff. Almost always it was at the normal atmospheric or a little higher. Why are we always high? This is why we are. The end result, you have a band of low pressure near the equator and bands of higher pressure near 30 north and 30 south. Okay? What's that? What's that again? What about it? Well, it depends on what scale you're using. It's usually near 30 inches of mercury. Near that, okay? Quite often you'll see it, especially if you have a hurricane and stuff, you'll see that is much, much lower. Okay. Now, what happens then, you have large convective cells that form to try to equalize the pressure. And that's one of your weather producers. Okay? Now, here's another. These things we call these large air masses. Okay? Now, air doesn't have a lot of mass, but it does have mass. And these are large, usually horizontally uniform bodies of air, and their moisture and temperature conditions are nearly the same. There's 4 main categories of these, not 3 but 4, okay? You have continental polar air masses. Those are usually over land mass and cold from the poles. You have maritime polar. These are usually over water near the poles, cool, but tend to be moist. These tend to be dry and cold. These tend to be wet and cold. Then you have continental tropical. That would be over land masses, but very warm temperatures. They could be hot and dry, usually are. Then you have maritime tropical, which are over warm, bodies of water. Okay, high moisture, high temperature. Okay, now these dictate what we call the air mass weather. Okay, weather conditions usually remain the same over several days because these are large air masses causing them. The weather changes when a new mass moves in or when the air mass acquires the local conditions. Okay? Now, right now outside, I don't know exactly what we're under the influence of. It's pretty warm temperatures for this time of year, but we haven't had any precipitation in probably a week or more, have we? A couple of weeks. It seems like a long time. So I would almost guess, I don't know for sure, but we've been under, and you see, they haven't changed. They remain the same over several days, so probably a pretty decent air mass.
So what would a maritime tropical weather be?
Okay, air mass. Let's take a look. Okay? Now, your picture in your book, by the way, this it looks a little different. Right.
Then it breaks down before you have to do it. But I'm trying to figure out what's different.
Okay. Okay. Let me say this about the picture, and then I want to ask you more. This is precipitation. The picture 23.5, a fantastic shot of a heavy rainstorm look like it's coming. And I just wanted to point that out because it was quite a picture. Now, what was your question again? I couldn't hear it all.
Okay. I see in the book where it said the 4 types, but then it described like air masses before it said something about the types.
Mm-hmm.
You see what I'm talking about in the bold?
Right.
It says like continental. Like, I don't,
Yeah. Okay.
It says polar, tropical, maritime, and continental.
Right. Okay. Okay. The only difference is they're saying polar continental. If you see, no, they're saying continental polar. You see the one that's coming in off of Canada, right in the middle. Continental polar. Are you looking in the text?
I'm looking in the text. Like they have right after the bold text, they have exactly what you got on the.
Right.
But I'm trying to figure out what the relationship between the bold and what you have up there.
Okay. Right. Okay. All right. Forget about these. You have either polar air masses or tropical air masses.
Okay.
Right? That's what's in the bold type. Polar air mass, tropical air mass. Okay? You also have air masses that would be continental or maritime. Okay? And then you combine them together and you get the various combinations. Okay? That's what's happening there. Now, this picture in the old slide compared to the one here, I think the new one is a little bit bigger because it's a lot. These look like tiny little air masses, you know, but it's basically the same. You got continental polar, basically for us, comes down out of Canada. Sometimes they'll call it a Canadian air mass. If you hear the weather, they usually don't talk about it much in the summertime, only in the wintertime. They say, we've got a continental air mass coming out of Canada, or we have a Canadian air mass, or sometimes they'll just call it a polar air mass, or but that's usually coming this way. That's our continental polar for us. Now, we have friends who live in Trieste, Italy. In fact, their son lived a year with us when he was doing his senior year in high school, because he was actually born in the U.S. The father, Fabio, was in the same class that my wife was in at UAB doing when they were working on the doctorate of epidemiology in public health. And so we became really good friends. And then when he got his degree, they moved to Boston, and that's where Giacomo was born. Ooh. So he was a U.S. Giacomo. It means James. Yeah. And so he was born in the U.S., so he is technically a U.S. citizen. And then they moved back to Italy after a couple of years, I guess. And then they came back again as Fabio did a postdoc type thing at UAB, and we got to meet the kids. 2 more daughters were born there, but they were born in Italy. So, and we enjoyed meeting the kids too. Well, later, we stayed in touch pretty much, Skyping and that kind of stuff. Not all the time, but periodically. And Karen had professional meetings in Italy, and it happened to be at a time when I could go over and join her. So it was at Thanksgiving. She had the meetings before Thanksgiving, and she had meetings in India. She went from Italy to India, and she came back to India right before Thanksgiving, in Italy right before Thanksgiving. That's when I went to meet her, and we went up to Trieste and met the family again. By this time, the kids was grown, and we got along really well with Giacomo, and his parents had already, he was really a bright kid and did very well in school, so they wanted him to have the opportunity to go to university either in Italy, which that would be no sweat, but also in America if he wanted to come here because he was a U.S. citizen. So they had been toying with the idea, trying to think of where he could go, and when we got along so well with him, they started looking into Birmingham and said, would you mind hosting him? No, sure, he's a good kid, great kid. So he spent his senior year living with us and going to a school near where we live. And then he went back to Italy, and in Italy they have 5 years of high school, so he graduated there as well. And then ultimately came back and he graduated from Harvard. And now he's back in Europe, working on his PhD in physics and he's now in Munich at the Max Planck Institute. But anyway, where I started all this, why did I start all this? Now I've forgotten, really. What's that?
The polar, the counter air.
The continental air mass.
Yeah.
When we visited in Trieste, and they were showing us around the city, right? It's on the Adriatic Sea. That's Italy's a boot, and at the top of the boot is a little curl on the boot, and that part is where Trieste is. So they're on the Adriatic, so most of the time they have really nice weather, but sometimes in the winter they have this polar air mass that comes straight out of Russia. And they say when it comes, it can blow cars into the sea. I mean, it is powerful and frigidly cold. So they know polar air masses, especially in the wintertime. And we've had these too, come down out of Canada, and sometimes those are bad. Okay, over here in Maine and New England, they have the maritime polar. Cold air coming off of Greenland and ice, maybe some Iceland and stuff, coming down the coast here. That's maritime polar. Cold but moist. This is cold and usually drier. Here in Pacific Northwest, again, maritime polar. Air coming out off of Alaska and the Aleutians and stuff coming in this way, maritime polar. Okay? Cold, moist air. Down here in San Diego and Los Angeles, you have maritime tropical, because this is coming from the tropics. This is coming up this way. Off of Mexico, you have tropical, okay? This is usually very dry air. And if you think about it, Mojave Desert here, the Painted Desert here, these are all very dry environments here because their dominant air mass is coming continental tropical. Not that much moisture. But we have the Gulf of Mexico. So we have maritime tropical coming up here, lots. And also from the east, from the tropical Atlantic too. So you have these major air masses that collide, contribute to our weather. Now, these dictate the air mass weather. Yeah, I already read that. And these are usually things that last for several days. Now, I haven't figured out what's causing the current pattern. It's warm enough, I would think it's the tropical, but most of our tropical is maritime, but it is pretty humid. We haven't gotten the rain out of it, but we have gotten pretty warm temperatures. So it's sort of hard to say, but we've had it for several days, so it would tend to make you think we have air mass weather dictating what's happening to us now. Okay? Now, and this part is sort of backwards. This is what I thought Anthony was talking about. In the text, the lead into weather producers talks about the fronts before it talks about the air masses. It talks about them and then talks about air masses, comes back to the fronts. So this is weather fronts around page 580. Okay? Now what are these? These are the boundaries between the air masses. Okay? So let's say, and this is what I was sort of conjecturing on, let's say we had a maritime tropical that had pushed its way up here. And here we have a continental polar, but it's pretty warm. It's not that bad anywhere else, so it's not all that cold of air. And it's pushing against this. And they may be battling it out now. And that may be why we haven't had any change for a while, is that neither one is able to move. There's probably what they call a stationary front somewhere in between. We've still got the temperatures from here, but the dryness from there. Okay? I'm just sort of making a guess there. That would be a front. It's the boundary between the air masses. Okay? So boundaries between air masses at different temperatures. A cold front would be if the polar air masses are pushing and moving the warmer air mass out of the way. That would be considered a cold front. The cold air mass moves into and displaces the warmer air mass upward. Now, I think this next slide is going to show that. Oh, it's not quite as pretty a picture as the one in the book. You might want to look at the one in the book. It's somewhat similar, but I'll use this one since it's up here. We just did a lab on contour mapping, right? And what were the contours? Lines of equal elevation. All along this line here, you were at 20 feet above sea level. This next one, you're at 30 feet. Next one, you're at 40 feet. You were at different levels above sea levels. And the lines were the contour lines. Those were isoclines, equal elevations. This is equal pressures. You call them isobars for barometric pressure. Here is a peak. This is sort of like a mountaintop or a hilltop. On the other, this would be a high pressure area here. Another one over here. Not quite as well defined here. There's one up here. There's part of one right there. Those are, not all that strong looking to me. But look at this flow over here. Now, this is actually a picture of, this is what they call a nor'easter. That is a low pressure maritime polar coming in, colliding with the air mass that was here, which was probably pretty much continental, whatever, probably tropical or just a continental air mass. So this is coming in this way, and here's the thing. Notice these lines are closer together. That means your pressure is changing more rapidly, like elevation. Now it's pressure changing rapidly. If the pressure changes rapidly, large winds, high winds. Whether the pressure is not changing much at all, typically are going to have very still days, not much breeze at all. Okay? Here you're going to have a lot of wind. Guess what a hurricane is? It's sort of like those cliffs. The lines are right almost on top of each other because those winds are fierce. Okay? So this is a low pressure area, and coming in, that's what they call a nor'easter storm. Okay? And the funny thing that it's the only low pressure I see on here. There probably are some others. The highs, this is the most defined high that they have shown. So those are what the fronts are. This is a cold front pushing in this way. Now I can't really see where they show it, but more than likely that's a cold front because this is probably pushing down this way. And that probably picks up here because the high pressure here and high pressure there are both pushing ahead. This one looks like it might be a little stronger, so this may be a warm front pushing up against this one, trying to shove that out of the way. It looks like another, so you see that's what the fronts are, the boundaries between the masses, the air masses. So, what's happening when the cold front comes in? Well, you had warm air in place. Here comes the cold air. So this forces the warm air up because warm air is less dense and it tends to rise. Okay? If that happens quite often, that's where you have that unstable air. That you could have some storms coming into that. Most of the time it's those cold air masses coming down that will produce our big weather makers. Okay? And this is shown from the side, pushing the warm air up. This is shown from the top. The front is moving in like this, and that's why they're almost always curved when you look at them, because they come in that way. So that's the cold air mass pushing the warm air out of the way. Cold air is winning cold front. Sometimes we have the warm air winning. The warm air mass is advancing over the cooler air mass. Okay? Now it's still going in the same direction, but this time you see, on this case, the cold air comes in and pushes up pretty quickly. Okay? And then it rises quickly. That can create convective flow. And the warm air mass, where is it? Okay, let's see. Evidently, it's missing. Okay, you have to look in your book. No, actually, they don't have a picture of it, do they? Okay, let's go back. Since your book has such a nice picture, on the top of page 580, you see it's not the same picture, but you can almost imagine that low pressure coming a little bit further in, kind of squeezing a high pressure and another high pressure that's a pretty strong one, but that one shows a low coming up from below. So again, these are lines of equal pressure called isobars. Now these are measured in, not in inches of mercury for sure. It looks like these could be measured in torrs or in millibars because they're such large numbers. This is more Canadian than it would be U.S. U.S. would usually measure it in inches of mercury. This is not inches of mercury, so I think there's. What's that?
I was talking to someone that lived in Colorado.
Uh-huh.
John said, Colorado.
Yeah, already it says like 41 up there, and they're getting snow. They got a lot of snow. Is that because they're getting it polar?
Okay, yeah, there's a couple reasons there. One, they're further north. But number two, and this is largely higher elevation. Okay? But number three, yes, they're more susceptible for the cold air coming down from Canada. By the time it gets to us, it's usually not that cold because it's just traveled over. See, the other thing is, if you go back to the previous slide, it says, or when the air mass acquires the local conditions. So, say again? Yeah, and what that means is as it's coming down, it's warming up. By the time it gets here, you can't tell a huge difference. It is cooler than what's above us. But yeah, but up there, come out of Canada, there's not much to block it. So it's all of those factors. Probably the air mass is predominant. I don't know for sure. The elevation is also really important too. Okay? Because it's acquired by the time it gets to us. Looky here. What in the world? Boy, he looks hungry today, doesn't he? Okay. Okay. Fred is here with bells on. Okay. Okay. I've begun to detect we sort of have a supper club here in this class, don't we? Okay. All right. All right. Good deal. Okay. What's that? Okay. Now, this is showing the same thing the previous one did, except that it has the clouds included. Okay? So here we have the cold air pushing against the warm air. Now, especially if this is warm maritime tropical, meaning it also has a lot of moisture in it. That's what we have. Most of our air mass coming up from below is maritime tropical. Warm, moist air. If the cold front's coming down from Canada, it hits that and pushes that warm, moist air up, and you get major thunderstorm there. This is cumulus cloud. You heard them talk about that before. look how high that cloud goes, up to 15 kilometers, which would be
Miles?
about 9 miles up.
Okay.
This is in kilometers. That would be about 9 miles up. Okay? And so you have some really huge weather maker here. Okay? The warm air is getting pushed up by the cold air mass. See how steep that cold air mass is? That's a quick climb up, and because it is, you can have convection and also some spinning motion. You could have tornadoes in that. Not necessarily, but you could. Okay? On the other hand, your warm front would be when the warm air mass comes and the cold air is in place already. The warm air comes and it sort of pushes its way. It's not bulldozing the warm air. It's sort of scooting up the cold air mass. So your gradient is a lot less. You know, the slope is a lot less. You still have cumulus clouds, but look, they don't go almost a quarter of what the other ones were. So it's not as major. You will have rain as that warm air goes up over the cold air, but it's usually light showers, nice soaking rain. A good condition. I like those kinds of showers, okay? Those thunderstorms that are really fierce, you get so much runoff, okay? So this would be your warm front. The warm air is pushing over the cold air, and see, in time, the cold air is going to retreat a little bit, but it's a much more gentle situation. This would be a more stable air mass, air situation than what the previous one. Now, occasionally, and this is okay, let me go back, sorry. The cold air mass is moved into and displaces warm air upward, very steep gradient. As it rises and cools, leading to large cumulus thunderous clouds, pretty severe rain you get out of that. On the warm front, on the other hand, the warm air mass advances over the cooler air mass, and now you have a long, gently sloping front, and the clouds and rain may form in advance of the front. The front is right here, or we sense it is. You usually get the rain a little ahead of that. Now,
That sounds kind of backwards up there.
what's that?
It's like in the springtime, when the warm air comes back,
Yeah.
it seems like we're getting just a regular little shower, but we get thunderstorms when the warm air comes back. And in the winter, when the cold air comes back, we don't really get, like now.
Yeah.
It's not going to be as bad as in the spring with the warm
Yeah.
air. So
Okay.
that sounds
Well,
backwards.
it's who's coming in when. Like this, actually, what we have in the spring and summer, the warm, moist air will be in place, and then the cold front comes down, and that's what creates the really bad thunderstorm. But we can have them any time of year, but it's usually when we have several days of pretty nice warm weather. You'll see the humidity drop come up, but it all happens pretty slowly. When that cold front comes in, that's when we have the severe weather. Whereas, and this can happen fall or spring or winter or whenever, but you see, and that's the other thing, and you sort of hit on something that was, went too far, pretty important here. What is the prevailing? Okay, in the springtime, like you say, right now, the prevailing situation is pretty moderate temperature. You don't have any huge differences. You can, and then you can have some serious things. But right now, it's just gradually getting cooler. Okay, but in the springtime, if that warm moist air comes up and it sort of builds here, but then you have that cold front come down, that's severe. I mean, that, yeah, and that's this picture here. And the, this could be spring or fall or any time. The cold air is in place, and then the warm air comes and just tends to rise above it, and you have the showers then ahead of it. And this could be any time of year. It's just whoever's winning. When the cold air wins, it's like a bulldozer. When the warm air wins, it's just going over the top. So it doesn't create as severe weather as you did the other time. You see, go back to your stable situation. The warm air was in place. It was happy. It was really fine. The cold air comes in and forces the warm air up. That's the unstable situation. Forces it up, and when it comes up, the moisture comes out of it real quickly with rotation and everything else. In this case, the cold air was in place, and here the warm air comes, but it doesn't force the cold air or anything, it just rises above it. And that's the more gentle situation. Because a lot of time in the spring you have very gentle showers too. It's just when you have the warm air there and the cold comes in, and the big deal is the big contrast. In the summertime, everything feels pretty warm. Even that cold air coming down is not that big a temperature difference. But when it does come down, you can have pretty severe weather. But in the springtime, that warm air may be quite warm, and that's still very cold air coming down from Canada because they haven't warmed up then. And that's when you get the previous one, and that is the severe stuff, okay? The rest of the time, like right now, it's fairly warm everywhere, and if you do have cold coming in, it's usually not that much colder than what we have now. But if you have cold air in place, the warm just rises above it, gives you some rain ahead of time, and that's it. Now, the stationary front, I don't think they show too well here. No, they don't show at all. What happens then is the forces influencing warm and cold, they become balanced. And sometimes when that happens, Willie's here. Okay. Boy, Willie won the door prize, didn't he? He came in and got a whole box of pizza. Okay. What happens then, the forces collide and neither one of them wins. And sometimes the front goes back and forth a little bit, and whichever you have rain and rain and rain because neither one of them moves. You really want to move. This is almost, not quite the same, of what happened in Texas with Harvey. Okay? It came in and then got balanced and just sat in the same place and just kept raining on the same area. And that was pretty bad. Okay? Of course, that was a much bigger and more powerful system. But man. But we've had other times, I can't remember, was it this year or last year sometime, someplace, it just started raining and just kept raining there. It wasn't super cells or anything else. It just started raining and just continued raining day after day. I think so. It was somewhere up in there. And they had flooding, not from any major system. It just was a stationary front that didn't move. We like to have the fronts move so everybody gets a little bit. Nobody gets oversaturated. All right, so those are our fronts. Now, before we leave this page, there's a Science and Society at the top of the page, and the title there is the Urban Heat Island. Have you ever heard that term? Okay. I wondered if it was really as major as they said, but what I have noticed this, especially come the second mini-term, when I'll be leaving here around 8 o'clock in the evening, and I'll be driving toward Birmingham, okay? Now I'm doing two things. It's 8 o'clock in the evening and getting later in the evening as I go, because you think it would be getting cooler, right? I'm also driving a little bit north, right? That's northeast, so you would think, if anything, it should be getting a little cooler. And the other thing is, because I'm driving east, the sun's been down longer in Birmingham than it has in Bethlehem. Not much, a few minutes, but, so it's been out of direct radiation. So you would think it would be getting cooler, right? Well, I'll leave here, and I have a thermometer on my display there,
Yeah.
and I'll see I'll just make up a temperature 74 degrees. I'll leave the parking lot and start heading out, and it might drop a degree or two, but then somewhere around Inslee or so, it starts going up. And I have actually seen it go almost 10 degrees warmer when I get into Birmingham than it was when I left Birmingham. Later at night, further north, further east, where the sun's been down longer, and yet it got warmer. Why? Because of that effect, the urban heat island. It's not global, that's more local. Okay? But if you think about it, what do you have in a city? Concrete, pavement, buildings.
They heat up.
And they heat up and they stay hot. And they re-radiate at night. Okay? Whereas in the community, out here we're still in somewhat city, but not nearly as dense as there. And here we have more trees, more grass. That just creates a cooler environment. Out in the country, and I grew up on a farm in Georgia, and it was always warmer in Augusta than it was out in the farm. Just about always. Because of the urban heat island effect. Okay?
You think that contributes to global warming?
It could. It certainly could, because those are such concentrated, and you have bigger and bigger cities these days. And think about the other part, and especially here in the U.S., this time of year, there's air conditioning in every one of those buildings. And you know what the air conditioning process is. You're pulling the hot air out and blowing it into the atmosphere. So you're heating it up that way too. You have more gas in cars, so you have more exhaust. So everything's contributing to higher temperatures there and lower temperatures in a more rural area. So it's a nice little blurb, several questions you can think about, and that could be a pretty decent paper topic. Paper topic. Here we are, 2-3 weeks to the end of the term, and I've got one paper in.
One paper in? Yeah, one paper. It was a group paper.
Okay. Oh, I see. Okay, yes.
I'm writing mine right now. You can expect it on Tuesday.
Okay, great. Good to hear. Okay. Get them in, people. Okay. There's another potential source. If you haven't even gotten so far as pick out a source yet, there would be a possibility. All right. The next topic within the weather producers are these waves and cyclones. Not the air masses, but something pretty big that could be happening with them. And they could be associated with fronts and things too. Okay? The mechanism here, you have bulges or waves often formed between these oppositely moving air masses. Okay? The overriding uplifted cold air produces low pressure because it's lifting, just like it did around the equator, low pressure. And further cold front motion leads to a occluded front and possibly a cyclonic storm. And that's why I said when these cold fronts are coming in, you can get, because that rise is so great, it's a steep rise, that can create the uplift and you get the circular motion. Yeah. Okay. And by the way, this goes back to the flushing the toilet in Rio. Did I tell you that one?
That's cyclone.
Yeah, exactly. When you have, in the northern hemisphere, when you have a low pressure area, you tend to have counterclockwise motion and high pressure area clockwise motion. In the southern hemisphere, it's reversed. Yes?
I read the other day that it doesn't actually change depending on where you're at. The equator is just by the design of the engineer. Like, the little swirl, how you talking about, like, depending if you're north or south of the equator.
Right.
I read the other day that it doesn't really matter where you're at. It can all it's the same way. It just kind of depends on the designer.
Okay, what is being designed? I didn't know.
The swirl, which way it goes. Like, if it goes counterclockwise, it's going to
Oh, you mean in the toilet or the tub or something like that? Yeah, okay. I understand what you're saying there. If sometimes the water comes in going in one direction, then it's going to continue to go. But if it comes in straight, you still will have sort of a flow. But on the equator, yeah, it all depends on which way the predominant, if there's any force at all, it's going to determine it. But the further north and south you have, the greater the tendency is. If there is no design feature there, it just is coming down, it will still spin. Like when you pull the plug on in the bathtub or the sink, the deep sink in the kitchen, you'll see that. And there's no design in that. That's just you pull the plug up and it goes down. And that's low pressure. It'll almost always be counterclockwise. Pay attention to it and see. Okay? Now, so.
Clockwise, it means something wrong.
Second? You may be in the wrong hemisphere. Okay. All right. Now, this next set of slides really doesn't do a lot for me, and it's in both texts, so they haven't improved it any. Here's the, and why they set it up this way, I don't know. They make it look like the warm air is on the bottom and cold air is on top. I think these are just moving past each other, not necessarily top and bottom, just past each other. And when this is happening, the bulges or waves often form between these opposite movements. That's what this is supposed to show. You have cold air coming in one way, warm air the other way, and I can't tell what they've done here, but the warm air tries to rise, the cold air tries to sink, and you get the bulge there, okay? Now, if the overall motion is this way, that's a warm front. If, however, the overall motion, the sign here, is pushing harder that way, then it's a cold front. So this is the difference that you have there. Okay, now, the overriding uplifted cold air produces a low pressure area. Now they say uplifted cold air. Should be the warm air being uplifted, so I can't quite follow what their logic is. Further cold front motion that's coming this way leads to an occluded front, which they don't really define too well. There's the picture of it. Yeah, it's at the bottom of page 582, the left-hand column. It says, within days after the first wave the wave first appears, the cold front completely overtakes the warm front, forming an occlusion. An occluded front is one that has been lifted completely off the ground into the atmosphere. The disturbance is now a cyclonic storm, meaning that at this point, you don't just have motion this way, you have circular motion. And that then creates the low pressure area. That's when the warm air is being lifted up through the cold air, and you have the cyclonic motion. Okay? Now that could happen anytime you have those fronts colliding, but the cold front is going, when it wins over the warm front, then you can have this. When the warm front wins over the cold front, you tend not to have this happening. And that's why you have the more severe weather when the cold fronts come in than when the warm. Doesn't mean you won't have problems with warm, but it's more likely. Now the cyclone is when the low pressure area with inflowing upward force winds. So you have low pressure spinning, and because it's low pressure, you tend to have air come down to fill that pressure, equalize the pressure. So you have the spinning and the motion of air, some rising, some falling, that creates the spin. And that comes from the Coriolis effect, which we mentioned before. That's the same one that does the spinning of the water in the tub, okay? Sometimes toilet, okay? Sink, whatever. The Coriolis effect is that effect that tends to make it spin. Now, if the warm front wound up winning, then you could produce high pressure area. The high pressure, the air is sinking, warm, relative humidity is lowered, and you tend not to have rainfall. Now, I'm wondering if we're not under high pressure right now, because we sure haven't had any rain for a while. And if anything, the humidity feels like it's dropping. I don't know that it is. Yes?
Don't get us all worried.
What's that?
Don't get us all worried.
Oh, there's nothing to worry about, but I don't like to water plants, okay? I want nature to water the plants. And I had to water some of the things on the patio last night, and I watered some the night before too. So, because you see, especially if you live in the Birmingham area, if you use city water, even if it's watering plants, you get charged more for sewage that's not going down the sewage you're using, because the sewage bill is higher than the water bill, which is ridiculous, but it's because of that sewage disaster we had many years ago we're still paying for now. Huh? Yes. Oh, no. The politicians wouldn't have done that, would they? No. All right. Which reminds me, you know what Tuesday is, right? Runoff elections. If any of you live in the Birmingham area, don't forget to vote on Tuesday. The mayor and some of the city council and board of education. Okay? All right. So that thing creates a cyclonic motion. Just having cyclonic motion doesn't mean you have a tornado, but it does mean you have a weather maker. And if you go back to that picture of that nor'easter coming in, they were going to have some pretty good storm there. Okay. Now, let me just tell you the story. The first time I heard the term the wave, okay, that's not like in a stadium or something, or people just saying hi. It was, I was doing a radon study down in Florida, and we had this building that was built to specs and stuff like this that we could study all we could come up with to study. We had, we were measuring soil moisture, soil radon levels, we were measuring inside temperatures, outside temperatures, we were measuring barometric pressure, all sorts of things. We had it wired for sound. We were collecting data continuously, data loggers going. And one day we collected the data and I was analyzing it, and my word, we had a huge dip in barometric pressure. And I thought, what could have caused that? And of course the radon level spiked because the soil gas was about the same pressure it was. The pressure in the atmosphere dropped basically, so it just sucked soil gas up into the building.
You said soil?
Soil.
Oh, okay.
In the dirt.
Oh, okay.
If you're not a soil scientist, you call it dirt. But dirt is what's on your clothes, soil is what's on the ground. So anyway, they and I called Jerry Tracy because I knew him from church. I said, what could have caused that? He said, oh, and this was down in Florida. He said, you probably had a tropical wave come through. And he said, yeah, that day, yep, I can see it on the map. Had that come through, and it just dropped it like crazy. So that's what the waves is, okay? So
it happened in like out of nowhere, tropical wave.
Well, they come out of the Atlantic. It wasn't out of nowhere, but it was just fairly sudden. I mean, a very steep drop in barometric pressure all of a sudden.
Yeah.
Yeah. And that's probably because that warm air got raised up over it. Yeah. Yeah, real quick. Okay. And those usually precede hurricanes and things like that too. So there wasn't one that time, but it still could. Oh. This graph is okay. It's in the text as well as in the old. These are some of the more common cyclonic paths across the U.S., okay? And these are the tracks that tornadoes typically follow. And for years, the predominant ones were around Oklahoma and Kansas and maybe a bit further north. These were the dominant ones. But boy, on May 2011, wasn't it? Or when was that?
Yeah, 2011. Yeah.
Yeah. Is that it?
Yeah, I think it's
Yeah. Boy, this was a track. All up and down here. I mean, the whole length of Alabama.
Yep.
I mean, there were tornadoes.
So,
Usually, if there's a tornado in the state, everybody's watching it.
yeah.
That day, they were just looking at the ones closest to us. Oh, there's a Category 5 up here, but that's not right. Category 5, who cares? Yeah, we're going to focus on these that are right here. There's only 2 or 3 of them right here that could hit us. And literally, we drove up to Smith Lake the next weekend to see if there was any damage up there. And it was just sort of like, there was a path as you went north on 65, just path after path after path. It was just unbelievable. I've never seen that many, that concentrated, that short of time. They had started the morning, they had a wave of them in the morning, and then another wave in the afternoon. It was an amazing day. And the next trip that we had to the Weather Center after that, Jerry Tracy was talking about some index that they look at to give them an idea of if they're going to have any problems. And it takes, air temperatures and air speeds and all over the place. And usually some things could be very suggestive of tornadic activity near the ground, but the upper air wasn't right. Or the upper air looks like it could really be right for it, but the lower air is not. Usually they sort of cancel each other out, sort of. He said this day, that index, and it's one they use, they don't ever report it that I've ever heard. He said that index was several times higher than they had ever seen it before. And they looked at each other and said, we don't even know what's about to happen, but it's going to be bad. Because the index was just out of sight. Everything that could be wrong was exactly lined up wrong, And so that was the path those took, came right across the Mississippi-Alabama border there. Okay. Now we go to the next major subtopic in weather producers, the major storms. And we've already been talking about them. These are rapid, violent weather changes, often associated with those frontal passages, the air masses, the cyclones, the whatever, okay? Often associated. 3 major types. Here we're back to our 3s again. The thunderstorms, tornadoes, and hurricanes. And basically, all 3 of these are slightly related to each other, sometimes more than slightly. But these are the mildest. These are actually, in intensity, are the greatest, but in overall, these are the biggest because they cover a bigger area. Okay? So let's look at. So again, you need to go back. What's that? Okay, a tsunami is not a weather event, it's a tidal wave, basically. And usually that's caused more by an earthquake. So it's not really a weather issue. Now, if you had constant wind, strong constant wind, over a broad span of ocean day after day after day, then that could cause a tsunami. So they can be caused by weather, but most of the severe ones are caused by earthquakes. What's that? A typhoon, tornadoes are basically, typhoons and hurricanes. I think they tend in the Pacific to call them typhoons, in the Atlantic the hurricanes. Same type phenomenon. Yeah. Cyclone and tornadoes sometimes are used interchangeably. Okay? So, thunderstorms usually develop in warm, very moist, unstable air. We've talked about all 3. We have warm, we have moist, and we can have the unstable. Okay? 3 stages for these. The first is the cumulus stage. This is associated with the convection. Okay? It could be caused by mountain barriers, but for here it's mostly convection, or cold front. Any one of those or combinations of those can cause it. Okay? And this is the A here corresponds to the one there. In other words, you have either convection, the warm air is rising, okay, or you hit the mountain barrier and the warm air rises, or the cold front and the warm air is forced up. Any of these could cause this, and this is a cumulus phase. You're accumulating the moisture, you might think of, and building these big thunder clouds. Okay? Now, after a while, and this is mostly updraft here, which is low pressure here. Okay? The updraft can no longer support, remember, it's warm air, very moist air. You've got to have the moisture. Warm air alone won't do it. You've got to have moisture. It's being drug up here. You're going 5, 10, up to 15, earlier slide showed 19 kilometers. That's up there, no, maybe 15. That's really high, and the higher you get, the colder it gets. So this warm, moist air then starts condensing, not just into water droplets, into ice crystals. It goes into, solidifies into ice crystals. Well, after a while, that the updraft can no longer support the ice crystals to keep getting bigger and bigger. They get heavy enough down the wind's blowing them up, but their weight is pulling them down. After a while, they start coming down. Okay? And they could be ice crystals or snowflakes on the way down. Now, in the wintertime, you could have a snow event because of this. Now, I don't know if y'all remember back in, goodness, when was that? 93 maybe?
Yeah.
Yes. Okay, remember that one? What was it? 14 inches of snow?
February.
Was it February? I was thinking it was late February. I was thinking it was March.
It was like a spring break or
I
something.
remember being pregnant, so.
Oh, yeah. She got pregnant.
I
Snow baby.
Okay. That's biology class. We're not going to go there. Okay. All right. But man, that was a thunderstorm, but happened with very cold temperatures up high. We got the snowfall then. And actually, more recently than that, and I can't remember what year it was, but there was that other one where that snow happened in the middle of the day, and it just, oh boy, people were spending for hours. Yeah, that was bad too. Okay, so the updraft no longer support falling, frozen water melts and becomes rain. Now, in the summertime, spring, summer, or most of the time down here, that frozen falling water, the ice crystals that were forming up here, they melt before they get to the bottom, and that forms rain. And some of those are the big old raindrops, and some of them are not big. However, if it's repeated accumulation, that the ice starts falling, but then another updraft pulls it up, the ice grows bigger, and then falls and bigger, then you get hailstones so big they don't melt completely, and that's where you get hail. I hate to see hail happen in the springtime when that could hit the peaches and destroy the peach crop. Oh boy, I love my peaches, and I can't stand for that to happen. But on the farm, that hail could hit right when the wheat is just about at its peak, and it can wipe out a lot of agriculture. Okay? So the following are hail accumulated ice formed by the accumulated ice crystals. Okay? And then finally, at the end, all the updrafts are exhausted, the rain is happening, the temperature is dropping, so you got downdrafts then as the rain just falls. That's the end, basically, of your thunderstorms. Now, we said thunderstorms. Let's see what everybody got this one. We're still writing. Okay, yeah. Okay. Yes.
I have a question. Cumulus nimbus, what does the nimbus part mean?
Okay. If you go back to the previous chapter, they describe all those things. I wish we had time to do that. We just don't. It's two different types of clouds. The cumulus are the big ones, and let's see if they show. Yeah. And they're just different types of clouds. And when they're integrating between the two, that's when it's cumulonimbus. Yeah.
Got it.
Yeah.
That's all I wanted to know.
Yeah. And then there's another one, cirrus. Everybody got that one? I was trying to see. They showed some earlier on one of the slides. I was wondering. No, they just show cumulus and cirrus. They don't show nimbus. I was hoping there was a picture of nimbus, but there wasn't. Okay. What's that?
I said, don't forget to get your speech before you go.
Okay, well, maybe while y'all are eating your test, if there's any left, I may get some. Y'all will be suffering, I'll be enjoying. Okay. Now, let's talk about lightning and thunder. We say them together. Are they connected?
No.
You better believe. No, they are. If you see lightning, somebody somewhere has thunder as well. You can never have lightning without thunder, nor can you have thunder without lightning. They go hand in glove. Okay? Sometimes one is so far away, you'll hear the thunder but never see the lightning. Other time you'll see lightning, but because of wind or something.
Thunder is the echo from the lightning.
Thunder comes from lightning. Yes. Yeah, lightning always happens first, then the thunder. If you're close to it, they're simultaneously.
Is it true that lightning comes down and hits the ground, then come back up?
Okay. Actually, lightning can go three ways. It can go cloud to ground, it can go ground to cloud, or it can go cloud to cloud. So there's three types of lightning.
Yeah, how that work?
Okay. We'll show that in just a second. Okay.
Yeah.
But hang on to that thought. So basically what we have, remember, we have all these updrafts, we have downdrafts, you have circulation, you have all sorts of movement going on. And anytime there's movement, just like when you're combing your hair with a rubber comb, and you get static electricity. That's it exactly. You're knocking electrons off of one type of thing onto another. And when something loses electrons, it becomes positively charged. If it gains extra electrons, it becomes negatively charged. And that's happening anytime you have the movement. Clouds moving past clouds, circulation, updraft, downdraft, any of that is going to be knocking off charges. Some things get positively charged, some things negative. The charges accumulate in different parts of the thunderhead. Now that's where the slide comes in, I think.
Where lightning come from?
Okay, we're getting there. Okay, so you have the charge centers happening from the motions. Okay, now where you have excess electrons and a deficit of electrons that's been created by the motion, when that gets strong enough, your electric potential gets strong enough, then you get discharge. And they go from here to there.
All that from the atmosphere.
Okay? That's within the cloud to cloud. But if your negative charge is here, your Earth then tends to be, that low-lying cloud is negatively charged, that pulls up positive charges, because unlike charges attract, the negative charges in the Earth get pushed back down. If this electric potential builds up enough, actually the lightning goes from the cloud to the ground. But over here, you have the deficit of charge. And because that's positively charged, it tends to pull the electrons up, maybe from here, and now you have ground to cloud. Because it's always the electrons moving, not the positive charges. So that is ground to cloud lightning. And this is cloud to cloud lightning. Always from the negative to the positive.
So, lightning can come out of the ground.
Yes, it can.
Is
Okay.
that common?
Huh?
Is that common? Like
Well, the thing is, it happens so frequently, you don't ever see which direction it's going.
True.
It just, you can't tell. Yeah, some people have taken slow motion, just been so lucky, they happen to be snapping a shot just when the lightning was sharp and you see it moving up.
Okay, can you get hit by that?
Yeah. If you're standing in that area, you could be fried. You could be
So
fried.
you can't have lightning without clouds?
Okay, that is a very good question. The question was, can you have lightning without clouds? Generally, you don't, but there are times when you do. For instance, air masses moving past each other. All it takes is relative motion. It doesn't have to be clouds. So if you have air masses moving past each other, that can happen as well. And in fact, out west, when you have some of the forest fires and things like that caused by lightning strikes, sometimes, and they actually call it heat lightning, because you have warm air moving up and colder air moving down without many clouds in sight, because it's just not that much moisture, but you can still have lightning there.
But you said that lightning without clouds.
Yeah, you can. It's not common, but it can happen. It's called, you hear them sometimes call it dry lightning or something like that. Anytime you have relative motion of air masses, you can have potential different setup. Yeah. Most of the time around here, you're going to have clouds.
So what's the purpose of a ground rod on top of like a lightning rod?
Okay. The reason for that is lightning always goes to basically the highest point. Okay? And if your house happens to be the highest point, then the lightning comes down and it finds the path of least resistance. I say lightning's a lot like students. They find the path of least resistance. Oh, I didn't say that. Okay. And and when we built our house in Georgia, we had what they call a submersible pump down at the bottom of the well. Okay. And when the lightning would hit somewhere close, and we were sort of up on a hill, it would find the best direct route was through that metal pipe down to the pump and blow it out. Just about every time. So we put up a lightning rod to direct it, otherwise take it to ground without going through our.
But lightning essentially comes out of the ground then.
Well, if it came that way, yeah, you could be. But you see, then that's so deep it's probably going to bypass it. It'll take that. Okay, what was your question?
Is that why lightning mostly hits trees?
Yes, that's why lightning will hit a tree. That's why thunderstorm come up. Oh, let me get under the tree so I won't get as wet. Yeah. Not a good idea. If there's thunder, there's lightning, not the best place to be. We have had on the farm, not often, but I can remember a few times we've had a cow to die because it was on top of a hill, and that's where the lightning hit. And yes, and when the vet checked her out to see why she died, her heart was about 2 or 3 times the size because it went lots of interior electrical stuff. It was immediate, and that's why you don't want to be outside of it.
Was it well done?
No, it was medium rare. Okay. But another thing is sometimes with a fence, back when we had, and I can remember when all our posts were wooden posts, and the barbed wire went across there like that. Nowadays we have metal posts, and they'll take it right to ground. But back when it was wooden posts, if the lightning hit a fence, it would carry along horizontally until it could find some way to get down. And if the cow happened to be standing too close to the fence, we had some of them get killed that way too. I can only remember 2 or 3 times that happened in the whole time I lived on the farm.
I had lightning hit fence in my backyard. They burned the top chain link fence all the way around.
Wow.
All the way around the house. Jumped over my gas main and hit the water line.
Oh, man.
You rather hit the gas?
Yeah.
It was right there. I don't want to hit that gas. It was amazing.
Well, it could have been the gas was in a plastic pipe, a rubber type thing, and it wouldn't be attracted to it. Okay. So, here's what's happening. You've got the movement of charges. That's what creates the potential difference. When the potential difference is great enough, you have discharge. Charges accumulate in different parts of the thunder. The lightning is the discharge between the charge centers. Okay? The discharge can be, like I said, cloud to ground, ground to cloud, or cloud to cloud. What happens, though, when lightning does strike, that you have an enormous amount of energy going through a pretty small space very suddenly. It heats up the air right around there where it happens really hot very quickly. And then when the lightning does, it collapses. That pressure and collapse, that's thunder. That's what sound is pressure, rarefaction. Pressure, rarefaction. That's what creates thunder.
Now,
Yeah.
is the charge in the earth on the ground rod, is it a negative charge? So it's a positive charge when the lightning coming out. Then when it hits the ground, it goes to negative charge.
Okay.
So that positive to negative.
Okay. The lightning is always movement of electrons, which are negative charges. So it's just up there. It's providing a way to ground. Now, if there's a negative charge center up there on the cloud, then that, light poles, light charges repel each other. So that's going to send the negatives down to ground and leaving positives up here, which creates a large potential difference. If that's a positive center up there, then the negatives are attracted up here and the positives. But either way, the lightning is going to go one way or another to do that and bypass your house. That's what you're trying to get it to do. And you take that and you drive that deep into the ground, down into the moist soil. And see, in a very desert environment, that's not going to be very effective, but then you don't have that much lightning out there anyway. Okay, so that's what the expanding pressure wave and the heated air produces the crack of thunder, because you have expansion, rarefaction, okay? And that's what creates the thunder. So you can't have one without the other. Now, yeah, you remember that one? Okay. One night, I told you about serving in the Navy. One night, it was early evening or late. It was one of the dog watches. You had 4 to 6 watch and a 6 to 8 watch, so you could eat supper. And it was one of the dog watches. I don't remember which one. I was out there on the bridge, no other ships around, and we had that night, the whole 2 hours, we stood out there on the thing and watched. It was like a network. It was all cloud-to-cloud lightning. And it was just all over the sky all night. That 2 hours just about continuous. It's just the most brilliant display of lightning I've ever seen. Not anything huge, no big bolts, but just constantly discharging. And I've never seen anything like that before.
Amazing if water didn't hit, lightning hit the water by the ship.
Yeah, well, actually, the ship makes a really good conductor. So yeah, you hope that's not going to hit you, especially if you're on an ammunition ship. Okay, yeah.
What they do for ship? Like you have a lightning rod for your house. They got anything to counteract?
Okay, actually, they have something. Do you notice that, especially in saltwater, ships tend to rust like crazy?
Yeah.
You ever notice that? And that's because, actually, what makes a battery is 2 dissimilar metals with a good conductor in between. They call it an electrolyte. And that's what a battery is most of your C-cell, dry cell batteries are carbon in the middle and zinc on the outside. And that's a potential difference of about 2 volts, In your car batteries, it's lead and lead sulfate, okay? They make great, that's each cell is about 2 volts. So 6 cells will be a 12-volt battery. So that's what makes it. Well, when you're out there in the salt water, if you have mostly steel and maybe a little bit of aluminum somewhere or some other metal, you've made yourself a battery, and that battery is going to discharge, exchange electrons, and you get rust and corrosion like crazy. So what U.S. naval ships do, they have right underneath on the flat part of the ship, just after the screw, have a huge big zinc plate. And that discharges and that corrodes away like crazy. Now those merchant ships, they probably had one at one time, but they don't want to take them out of the surface, so they just rust. Okay? But in the Navy, every 4 to 6 years, every ship goes into the overhaul. Now they update equipment and stuff like this, but the main thing they do in overhaul is change those plates. And that prevents the rest of the ship from rusting as badly. But the commercial light ships, they don't want to take them out of the water, so they rust like buckets. Okay. So, so they have something to act like the thing to discharge the charge they build up. Because the ship is moving through the water, motion of water against ship, it tends to exchange electrons. So you want the plate, the zinc plate, to do all the electron exchange and not your metal in the ship. Okay, and then places where you have, say, a railing that you want to be aluminum because it's lighter weight, you have to make sure you have a good rubber gasket in between the metal and the aluminum, otherwise you get corrosion. They call it bimetallic corrosion. Basically, you've made a battery. Now, with you guys, I hate to ask this question, but have you ever had a battery in your mouth?
Yeah.
Yeah, of course you have. I said the guys are going to do it. They're going to do it. But even you gals probably have without putting a battery in your mouth. Yeah. We said guys, didn't we? No, I didn't say that. Okay, sorry. Okay. No. Here's what.
That's how you see if the 9-volt battery still working.
Okay. But I can't say that all of you have had it before, but my guess most of you have.
Yes.
Have you ever accidentally bit down on a piece of aluminum?
Yeah.
It hurts like crazy. Why? You have a battery in your mouth. Because if you have any fillings in your mouth, those are silver composite, one metal, aluminum's a different metal. Your saliva is an excellent conductor, electrolyte. That's why it hurt like crazy, because you just sent a charge right through your nerve. And that filling is real close to your nerve in your tooth. Oh boy, you felt a battery in your mouth. Why would any sane person have a battery in your mouth if you bite it down a piece of it? What's that? No, the guys actually put batteries in their mouth. But if you've ever been on a piece of aluminum, like, you know, remember when chewing gum used to come in full wrap?
Yeah.
If you happen to get part of that, oh man. Okay. All right. Now let's move to the second. Thunderstorms have a lot of energy being generated, but tornadoes are the smallest but most violent of the weather disturbances. It's like they focus all their energy in one little place. Rapidly whirling column of air, diameter is usually 1 to 400 meters. Usually. Now, 400 meters, if you think about it, is about, 100 meters is a football field long, but that's how wide it is. 400 meters, it's about a quarter of a mile. But you know, some of the ones that went through on that day were close to a mile wide. And some of them out in Kansas and some other places, when they really build up steam, they have been close to a mile wide. And those are devastating.
So, how wide is the one that hit Puerto Rico?
Now that was a hurricane, wasn't it? Yeah, and it was huge. Hurricanes are much bigger than tornadoes. And it was poor Puerto Rico. Wiped out their entire electrical grid. All the electricity that's happening in Puerto Rico right now is by generators or batteries. That's all they got. And they're running out of gas. Yeah. Okay, and no fresh water. I mean, the pure water. No way to purify water. They're in serious trouble. So wind speeds up to 480 kilometers per hour. 480 kilometers. That would be about 250 miles an hour. Yo! Okay. Damage produced by the high winds. But where did the high winds come from? Drop of pressure. That's what's happening. That's what makes the winds go so fast. Now, that drop of pressure, if you think about it, what is usually one of the worst damages that happens when a tornado hits a house? The ceiling is lifted off. The roof is lifted off because the pressure difference is so great. Inside the house is still the regular pressure. Outside is not. And basically, if you're in a house when a tornado is hitting, more than likely, unless a limb comes flying through the window, most of the time the glass blows out because the pressure is greater inside than outside. So most of the time it goes out unless a limb or a block or something comes in. Then.
So it's best to let the windows up to let the pressure rise?
What's that?
It's best to let the windows up so you can equalize the pressure?
You mean let them bulk? Yeah.
That's what they used to do a long time ago.
Oh, I see what you're saying, yeah. And actually, that is a thing that people didn't want all the rain coming in. But that is a safe thing to do. I couldn't understand what you're saying. Yeah, yes.
I was in a tornado. The tornadoes that hit it last year over in the Ocala area. I didn't know, I thought it was just a regular storm, and I had the back window open and the front window open that had a crank. And I didn't know that the tornado was next door and tearing up their house. The water was coming straight in at me. I thought it was a storm, and I was trying to crank the window closed.
Right.
The floor is one of those floating floors, and the floor came up. It was
Wow.
all of the pressure that would have stayed outside ended up in the house. All of the dust from when the house was built about 6 years ago came out. All of the pressure was in the walls.
Yeah.
So all of the dust from inside the walls came out from under the
Yeah.
walls. All the floors moved. Windows, I had smashed windows.
Yeah.
So don't open your window when there is a tornado, because then the pressure comes inside the house and it'll do damage from the inside out.
Yeah. The thing is, if one's in the area, you got serious problems. I mean, no matter what, you got serious problems.
Buy you a tiny house.
And, you know, things are lifted. Okay. Damage produced by the high wind, drop in pressure at the center, flying debris, that's where the real danger, a lot of the danger is. And it's associated quite often with these very intense thunderstorms. That's what spawns the tornadoes. And it's always where you have, the front is where the cold air and the hot air are colliding. And what do they look at on the weather thing? If they see that Doppler effect, the winds are going in opposite directions because you have cold air, hot air colliding. And there is a picture of one. I think this was Dallas, Texas. I think the one in your book is Marquette, Kansas. Okay, you just don't want to see them. Okay. All right. We mentioned hail. There is a figure in your book, figure 2317, a picture of hailstone, size of one fell in Iowa, damaging automobile structures and crops. You don't want that size of hail to be falling near you. Okay. Then the third, and these are really the most powerful, but they're not the most concentrated. These are the hurricanes. Ask Houston, Florida, and Puerto Rico about this. It starts with a tropical depression. Again, remember in the tropics, the air rises, the warm air rises, leaving you low pressure, and that's where it begins. A tropical depression, an area of low pressure. The winds are generally moving about 55 kilometers per hour or less in that low pressure area, and that would be about 30 miles per hour. Okay, so not too bad. Plenty strong, but not too bad. Then if it continues to build and your pressure drops even lower, your winds pick up speed and now move up to about 70 miles per hour. This is now a tropical storm. And if they continue and that pressure drops, very intense low pressure, drops like the bottom falls out, the winds exceed 120, which is exceeding 70 miles per hour, you now have a fully developed hurricane. Now, the surprising thing is, in the center of the hurricane is the eye, which is perfectly calm. Okay? And that's where the birds will accumulate and stuff. Your ears may pop because the pressure is so low in there. And I told you about a friend of mine that, after being a forestry major at the University of Georgia, decided to become a pilot. He did, and he couldn't get on with the airlines because they weren't hiring. So he flew for NOAA, and he was a hurricane jumper. You know, he would fly into the eye of the hurricane, take the measurements, and then fly back out.
Kamikaze.
What's that?
Kamikaze.
No, he'd go way high and try to avoid most of the intense stuff. Oh, yeah. Well, no, I'm just going to, yeah. This is a picture of the eye. I can't remember which storm that was. It was in the old text. It was one I hadn't heard of. I thought maybe it was Andrew because I remembered Andrew looking a lot like that. But it was just any old hurricane. This is the eye where you have basically very calm air But all around there, I mean, right around the eye, the wall of the eye, I mean, the winds are blowing almost like you were talking about horizontally. You know, they're blowing so fast. Okay. Fully developed hurricane has a calm eye surrounded by intense rain and thunderstorms all through there. Now, quite often in the outer band, you can have tornadoes come out of the hurricane. And, yeah. And let's see, we got just a little bit of rain from Harvey. I can't remember if we got any from Irma, because that tended to go east of us. Yeah. What's that? We got some. We had such a nice summer as far as regular rains. It was just really good. Last summer, when it was so dry here, that's one of the few times Georgia got more rain than us, because they had 2 tropical depressions that went up through them that dropped lots of rainfall we didn't get. You know, so, that's where the farm is in Georgia. So my brothers are always talking about the weather. My older brother can tell you how many inches he got every month. I mean, he's just, I guess there's not much to do out there. He pays attention.
Wait, I'm not.
Yeah, I'm waiting. Okay. All right, the 10 o'clock scholars. All right, Trey is here. And Kiara is here. Okay. Still missing. Who is we missing here? Oh, Jarrell, Sean, Angel, and Kedrick. 4 guys.
See your piece swinging over there.
Okay, got it? All right. Well, I could have changed it. I didn't know it was a novel. Okay, here's what's happening with a hurricane. Now, in many ways, this looks a lot like your thunderstorm, and in many ways it is fairly similar, just much, much bigger. Okay? And this is your cutaway view. You've cut the hurricane in half here. This is your eye here. And low pressure, so air is coming down into that to try to equalize the pressure. But then it's spinning like crazy. And again, this time it's definitely counterclockwise in the northern hemisphere, clockwise in the southern hemisphere. Low pressure, very low pressure. And you have the updraft here because of the spinning, and that's your that change of motion there that creates it. The eye is here. You have hurricane force wind basically within this band, gale force winds or tropical storm winds outside of that. Okay? Your maximum winds are right near the eye and inland for about half of the distance there. Really, really powerful. And look at the distance. The eye can be as much as close to, I'd say 30 to 40 miles wide. This is a major one, which would be, this is kilometers, not miles. So 30 kilometers would be about 18 miles wide. And then the hurricane winds can go out to 50 miles to a 100-mile diameter there. Because remember, this is going 3-dimensional here, so you have it coming out this way too. So a 100-kilometer diameter, which would be 60-mile diameter. That's huge. And then some of them are much bigger than that. Okay, this is just one. And your gale force winds are then up to like 80 kilometers, 90 kilometers out. So that could be 500 55 miles wide that way.
So
Some of them are much bigger than this. Yes.
So when they go flying to the eye, how far down are they going? Are they just at the top?
They could go anywhere up and down there. It's pretty good flying because you got plenty of room to maneuver around there. And they're probably measuring pressures up and down, temperatures up and down. I don't know. I never went with them. And not about.
From the top.
Yeah, they fly over the top, and like if you've ever been on an airplane and they've hit rough weather, they try to get up and go over it. So that's what they do. They try to go over the really rough. They still have turbulence. I'm sure they do. And then they drop down and fly around inside the eye. Yeah, taking measurements as they go. I don't know exactly how they did it, but I'm guessing they went all up and down to get the full picture. Okay, now we get to 23.3. And by the way, there's a concept applied here, actually two of them. One on tornado damage. I'm surprised they didn't have this earlier, didn't have it in the slide, but they didn't. Tornadoes are rated on wind speed and damage, okay? And the light damage, the category 0 tornado. Light damage, winds under 75 miles an hour. You can have damage to chimneys, tree limbs, small trees, and they should talk about shingles. Shingles are blown off like crazy.
Three-dimensional single tap.
Good when it did.
Yeah. Okay? Now, at the farm, I wasn't there, but I've seen the result of it. A category 0 went and cut across our farm. Did I tell y'all this story?
No.
Category 0 tornado. Okay? It happened to be the weekend that my younger brother's older daughter, husband, fiance, and his family were invited to the farm. They were exchanging parents. And both of my younger brother's kids have all married really well. It's the weird farm. Here we were, just farmers in Georgia, I think it's my younger brother's means of getting better Social Security, but I'm not sure about that. But anyway, his daughter was engaged to, and I was married to, the son of the chair of pediatrics at Ohio State University. Okay? But they're really nice people. So here they came down to Georgia this nice spring day, and we're out, and Dan said, well, they're calling for some rough weather a little bit later. Let me show you the farm before the storm gets here. So he had them out in the cow pasture, showing them the thing, driving them around in a pickup truck. I'm sure they thought it was so much fun, but my brother thinks it's great. And they heard something and just felt something strange, and the sky color sort of went a little weird, and they just sort of glanced over, and they saw a tornado crossing our neighboring farm's field. And they said, let's head to a low area. They turned around. The cows that had been out in the cow pasture, cows were nowhere in sight. Cows had more sense than they did. They were out of there, okay? They disappeared. And so they got down into a ditch, where they had put concrete block and stuff to keep it from running, eroding badly. They're welcome to the farm, crawl around in a ditch, but that's what they did. And the tornado went through, cut a path of, just took out trees, and literally it was, I'm guessing 30 to 40 feet wide, this path. I mean, dense trees. My mother's yard, she's not there anymore, but she was then, just cut up, took half of her magnolia off, actually curved around the house, took off a few shingles at the front corner, took out that, went around the house and wiped out the shop, which was concrete block. I mean, hardly 2 concrete blocks on top of each other. In fact, they couldn't even find them all. The roof, it took them a long time to find. It had been transported somewhere down into the woods. Category 0. So you don't mess with any tornado. If you hear one coming, hit the ditch, okay? Don't be in a car. Get down in the ditch. Okay. Category 1 from 76 to 112 miles per hour wind. Roofing materials removed. That happens in Category 0 too. Mobile homes, moving autos, pushed around, overturned. Don't be in a mobile home or an automobile. Category 2, considerable damage. That's 113 to 155 mile an hour wind. Roofs torn off the house, actually lifted off the house, okay, because the pressure is so, the pressure difference is so much. Mobile homes demolished, boxcars overturned, large trees snapped and uprooted. And by the way, when we were heading to the to check out the thing at Smith Lake after the tornadoes, we drove through that area off of Coldberg Road, where the Swift trucking and stuff, all those tractor trailers, the trailers are there. I mean, it looked like a kid had taken his. All right, got that. All right, those trailers. I mean, it looked like, a kid had gone in there and just thrown over his building blocks. I mean, they were just all over the place, upside down, turned over. It was amazing. Okay. Category 3, 156 to 205 miles an hour. Roofs and some walls torn off homes. Whole trains overturned. Most trees uprooted, not just broken limbs, uprooted. Cars lifted off the ground and thrown around somewhere. Okay? Category 4, devastating damage. Winds from 206 to 260 miles per hour. Homes are leveled. Cars are thrown. Large missiles are generated. You don't want to be by a window then. Big things can come flying through windows. Category 5, incredible damage. Winds from 261 to 318 miles an hour. Homes are demolished, swept away. Automobile-sized missiles are flying through the air. Do you remember the Twister, the movie? Helen Hunt, I think, was in it.
Never seen it.
I haven't seen it either. They showed cows flying around in the air. I have never seen that, but it could happen. Okay.
That happens in Wizard of Oz too.
Oh, really? Okay, right, yeah. Okay. So, automobile-sized missiles fly through the air more than a football field in length. That's amazing. Trees are actually debarked. Huh? That's 5. That's 5. I remember another, it was a fairly small tornado that went through our area. A little bit hit our farm, but not very badly. But someone said they found a pine needle that had been, they thought, embedded into a power pole, just sticking there, until they realized it was on its way out of the power pole. It had gone in the other side and almost made it out before it lost it. What's that?
I heard people saying that.
Yeah.
Because you was in the wooded area.
Yeah. And that same one, I remember, it took the roof completely off of a house, damaged everything in the house except the kitchen table was there with a little vase with a rose in it. It was left alone. Everything else in the house destroyed. Just really bizarre. Okay. I didn't see it, but I heard about that. Okay, there's one concept supplied. The other one, the other page, 587, hurricanes are classified according to the category and damage to be expected. Now, they don't have a category 0, but they have category 1 minimal. That's 75 to 95 miles an hour. That would be a category 0 tornado. Moderate, category 2, 96 to 110 miles an hour, that basically is a Category 1 tornado. Category 3 hurricane, extensive damage, that would be 111 to 130 miles per hour wind. That's approximately a Category 2 tornado. Category 4 hurricane, 131 to 155 miles per hour. That's basically an upper class Category 2 tornado. And then the catastrophic number, Category 5, this was originally, I think, all three of the big hurricanes this year, Harvey, Irma, and Maria, I think all at one time were Category 5s. Yeah. I think before they hit land, they had slowed down a little bit.
Irma was,
yeah. I don't remember Maria either, but I remember when it happened. But anyway, catastrophic over 155 mile an hour wind, but that, by the way, is only a Category 3 tornado. 3, 4, and 5 are all greater than the wind speed of a hurricane. Of course, a hurricane is much more powerful because it covers a much bigger area, but tornadoes are intense. Really, really intense. All right, now to 23.3, weather forecasting. Based on mathematical models of the atmosphere, okay? The atmosphere covers the whole Earth, right? That's a huge surface, and it goes up for miles and miles and miles. So how in the world do you model that? Well, you have to get data points. Yeah. Now, a lot of planes have devices on them, and as they're taking off and landing, they'll get that, and they'll send it to the weather centers. Not all planes, but they do. So they can collect a lot. They send up weather balloons about 2, maybe 3 times a week, and that's just in certain locations, and they measure temperatures, wind speeds, and stuff as they go up. They collect those data. But basically, you get very little data, and you have to build these huge models on very little data. Okay? That's hard to do. And you get more data, and it's hard to calculate. Okay? Billions, with a B, of calculations necessitate the use of supercomputers. Before we had computers, it was a best guess. Okay? With computers, they were able to get a little better. Now that we have the supercomputers, we have the best models ever. And they're still pretty weak. Because that's still so many calculations based on so little data. Okay?
So, now, go ahead. We'll talk later.
Here's the thing. Here's what the book says. Fairly accurate forecasts can be made up to 3 days, and those are possible. You can make good guesses past that, but that's all they are. And what does every weather channel say? 7-day forecast, you know? If you were to track that 7th day, and then the next day it's the 6th day, and the next day, you'll see they're guesses. They're their best guess. But you see, by the time they get to 1 to 3 days, then they're pretty good. But when they're out there, their best guesses is all they are.
So when we go to the station, can I ask him why he tell lies?
He'll probably tell you they're our best guesses. Now, what's the major uncertainty here? Insufficient technology to connect the small and large-scale events. Okay? They just don't have.
We ain't got the technology to predict the weather, but we can send a rocket to the moon. That's kind of hard to believe.
Well, sending a rocket to the moon has probably fewer variables than the one to predict the weather because there's so many things. There are, it seems like something like 7 levels of the atmosphere. And one can be doing one thing, one can be doing something else. The temperature differences are huge. It's just incredible. And then they talk about the jet stream dipping down or going up. There's just so many things that can change. That's what you
just have to calculate all that before they launch a rocket.
Well, but they basically, that's just one location. Weather is predicted over a huge area.
But they can pinpoint one location.
Exactly.
Oh, okay.
Yeah, that's how they do all the math calculations to where they don't throw them off course or, you know.
Oh.
And what's more, the oceanic influences need to be better understood. And guess what? We probably know more about the moon than we do about our own oceans.
Yeah, that's weird.
And that is weird. Because there's many...
The ocean is, we don't know.
Pacific. We don't know about the Pacific. We know about the Atlantic.
Yeah.
We know a lot of things about it, but there have been places in the Atlantic that no vessel has probably gone within close enough to see. You know, because it's huge. Huh?
You have to be able to build something to hold the pressure.
Well, the thing is, and even if we got there, next week it may look totally different because things are always changing everywhere.
You ought to be able to put a satellite down.
So are you traveling light years down through the ocean?
Yeah,
What's
they
that?
call it light travel.
Light years. Are you
Yeah.
traveling
Light
light
years
years through the ocean?
But okay, talking about light though,
Because
if you go to the bottom, even the Gulf of Mexico, which is not at all as deep as the ocean, total blackness.
Right.
Light doesn't make its way down more than a few meters, you know. And so it's just amazing. And the pressures, you talk about the pressure difference from here to outer space is far less than the pressure difference from here to halfway down in the ocean. I mean, that you're talking huge, huge pressures. Okay. That's the first half. That's the weather half of the chapter.
By time for a break, I mean,
Yeah, we
who
can.
said break?
Yes, please.
All right. Actually, climate would be a great place. I can't believe this is a major.
See, I got about 10 more 12 pages.
All right. So let's do a quick break. All right, I guess we're ready to go again. I guess the others will be coming back. I'll call roll again in about 5 minutes or so. Okay. Now, a pretty good definition here is right at the beginning of climate. They say changes in the atmospheric conditions. Okay, changes in the atmospheric conditions. Changes in the atmospheric conditions over a brief period of time, such as a day or a week, are referred to as changes in weather. That's a good definition of weather. Weather changes follow a yearly pattern of seasons that are referred to as winter weather, summer, winter weather, so on. All of these changes are part of a composite, larger picture, and that's called climate. The larger weather patterns occurring over numbers of years, that's climate. Over a few days or weeks, weather. Over a number of years, climate.
So they can actually predict what the weather's gonna be. That's how they tell you it's 10 degrees higher than the normal weather.
Yeah.
Okay.
Because they gathered data for probably close to 100 years.
Okay.
Some of that data a long time ago wasn't all that great a data, but they have been collecting for quite a
What
while.
they collected the wood back then?
Huh?
When they collected wood back then?
How
did they collect it back in the day?
Well, they had thermometers, they had anemometers, they just collected some things. They couldn't do as much, but here, talk about 10 o'clock scholars. This is 10:30 scholars here. Okay, Sean's here. Just barely made it in, huh? Okay. All right. Climate is the determining factor in many things. Okay? One of these is the types of plants or animals at a given location. Now, I can remember when I lived in Nebraska, I was there for 5 years. I crammed a 3-year program into 5. And when I was... when I was there, I remember people talking about seeing their first armadillo.
Really?
ever. Because armadillos didn't used to make it up to Nebraska.
No.
They were something down around Texas, Louisiana. They had armadillos there.
They made up to Texas.
They made it up to Nebraska.
Oh, it's cold up there.
Yeah. And armadillos were there. Okay? Does anyone ever heard of a thing called fire ants?
Yeah, they put me in the hospital.
Okay.
Yeah.
Fire ants didn't used to be here.
Really?
Fire
Where
ants
are they?
were down in the tropical areas.
Okay.
Uh,
How they get it? I need to find him.
On the farm, I can remember when I was young, never seeing these, never seen them, and it's only in the last, I'd say, decade or two. Have y'all ever heard of the bird called cattle egret?
Nope.
A beautiful white bird. They're pretty clumsy looking on the ground, but they fly so beautifully. They hang around all of our herds of cattle now on the farm, eating the flies and things like this. Fantastic natural pesticide, but when I was young, I never saw a cattle. I never had heard of a cattle egret before. So yeah, types of plants or animals at a given location.
What about lightning bugs?
Lightning bugs, it seems like I've read they're sort of indigenous to the U.S. I don't know if in Europe they usually see lightning bugs. So yeah, there are all sorts of things. Also, the types of houses built. Now, if you look at this campus, there is one building on this campus that doesn't have a flat roof. And that's the Jess Lanier building. And that's just because they put a new roof on it because the other one leaked so badly. On the Birmingham campus, I think the only one is the ACAP building with a tilted roof. All the rest of them flat roofs. Would they do this, say, in New York, Minnesota?
No.
Why not?
They don't have flat ones up there.
Why not? Yeah, the snow caved them in like crazy, okay? Huge accumulations of snow. So the types of houses built. Have you seen these chalets in France in the Alps? I mean, those roofs are like that. So the snow will go off of them and not, pile off. So yeah, the types of houses built. Also, we have what we call crawl space houses.
Yeah.
Okay? They don't do that up north. Because then you'd be freezing every pipe underneath your house because the weather gets so cold there. Okay? So yeah, the types of houses built, we can get by with very minimal insulation. It's not a good idea, but you can. Up there, you better not have the minimal insulation. You'll freeze to death. Okay? Also, lifestyles. What states produce the most football players, you think? Florida, California, Texas, Alabama, the southern states. How about hockey players? Oh yeah, we don't produce very many of them at all, okay? So our lifestyles are very different depending on everybody ice skates in Canada, it seems like. I've been on ice a couple times and don't want to go back, okay? It's miserable, okay? No fun there at all. And okay.
A lot of it in Canada is inhabitable, no?
What's that? A lot of Canada?
Much of Canada is
uninhabitable.
Uninhabitable, no?
Perhaps. I wouldn't want to have it there. Yeah, exactly. However, I mean, there are Inuits, Eskimos, that's their environment.
No,
Inuits.
What is that?
Yeah, that's the actual name. We call them Eskimos, but
The proper name.
Oh.
okay.
Oh, you do.
Climate influences the shape of a landscape. Okay. How things look. Okay. Types of soil. Boy, poor southeastern U.S. We have such high temperatures, great waterfall, rainfall and stuff. We weather our soils away. Our soils are called ultisols, ultimately weathered. In the Midwest, mollisols. Those topsoils go down for feet, because they don't weather as quickly. So the types of soils vary greatly according to the climate. Also, agricultural type and productivity. Yes? Oh, it is time, is it? Thank you so much. Okay.
We get time for the next shit.
All right. Hunter is still here, mostly. Chandra's still here. Rachel was here. I'm sure she'll be back.
Oh yeah. She went to
Ray is still here. Wait. Trey is still here. I've got to get the right order here. Trey is still here. Ray is still here. But Jarrell hasn't come in today yet. Okay? Cece's still here. Anthony's still here. Sean just has gotten here, but he made it in time. Fred's still here with pizza. Okay. Chelsea is not here now. I guess she's coming back.
Yeah, she is.
And Rachel made it back. Sam is mostly here.
Yeah, I'm on.
Okay. Nick is still here. Melva's still here. Telling me to call roll. Okay, Willie's still here. Lisa's still here.
Yeah, I know that.
Tiara's still here. And Angel hasn't made it in today yet.
No.
Ashlyn's still here.
What is it?
And Kedrick hasn't made it in, actually, in a while. Pretty good, long while. Okay?
Yeah, he working.
So, agricultural type and productivity, yeah, that's influenced by climate. For instance, how many orange groves are around here? Not a one. They just won't make it. How many pecan orchards do they have in Minnesota? None, okay, yeah. There's just some plants. How many pineapples do we grow around here? None, you know. Sugar cane, down south, but not here. Yeah, different things grow in different areas. Now, the Midwest, those soils are so rich, they can plant their crops in very tight rows, many seeds per row, still have great harvest. Here we spread things out, you know, stuff because our soils just aren't that good. If we fertilize like crazy, we might be able to, but that's not cost effective. However, what we can do they can't do in the Midwest, we can double crop. My dad used to put wheat and oats and rye out. He'd sow that in this time of year, maybe. Actually, usually wait till November, I think. So that it would grow a little bit before it got real cold, then hang around. And then actually, while it's hanging around, he would graze it for winter grazing because the Bermuda grass had died back, but that wheat and oats and rye, yeah, they could still graze on that. And then come spring, it would get up, and he'd cut the wheat and stuff around May. Then he could plow the field up again, plant soybeans or corn, and get a second crop on the same field. Now, he didn't do that always, but he could. You know, we can double crop. In Iowa, they pray that the spring comes early enough they can get the soil prepared before the heavy rains come, but you know the soil is warm enough to plant the seed. Otherwise, they don't have a long enough growing season to grow their crop because it can actually be too short. Minnesota even worse. So even though they have rich soil, because it's not heavily weathered, they don't have the weathering to grow the one crop. Mosquitoes, I think. No, I'm not. Just kidding. Yeah. No, they do. I think they do a fair amount of dairy farming. I know Wisconsin does a huge amount of dairy farming. Yes.
Yeah.
So you're saying that crops depend on the soil and the weather.
Yeah, and soil depends on the weather too, or the climate. Long-term effects of climate. Yeah. Soil doesn't depend on day-to-day weather, but it turns on the long-term weather.
Longevity.
Yeah. And by the way, do you know what the driest month is in Alabama on average? No, actually. Well, it used to be October, unless it's changed. No, actually October. But the thing is, the plants aren't using so much moisture then, so who cares? I mean, it doesn't matter. In July, you can have more rain than you have in October, but just a little bit more plants are going to die because there's so much the heat is just taking the water out of them like crazy. So yeah, wet climate is the long term, okay, overall. That doesn't mean we might not have a wet October coming up this year, but overall, like you said, averaged over time, is the driest month, or it used to be anyway. Oh yeah, my dad used to use it a lot, and you know, all they look at is what it's been over the last 50 years, average that out, and say that's what it's going to be this year. And they'll be right more often than not, okay? But, you know, sometimes very wrong. Okay, let's look at some of the climate groups. Two primary factors, only two this time. The intensity of the incoming solar radiation. We saw this back in the early part of the chapter and earlier chapters. Yeah, that's a big factor. How much solar radiation is coming in. Now, it's not that the equator is that much closer to the sun than the North Pole. That's negligible difference. What it is, the sun hits the equator at close to 90 degrees. It hits the North Pole at a glancing angle. Not as much gets through. It goes through a lot more atmosphere at the North Pole. It goes through just the minimal atmosphere coming in at the equator, determined by the angle of incidence. Along the equatorial region, the tropics, minimum angle of incidence. Near the poles, maximum angle of incidence. So it is far less direct radiation. And the number of daylight hours. Okay? Around the equator, almost always 12 and 12. Where we live, we did the numbers. Remember, 14 in the summer and 9 in the winter, something like that. I mean, it's just amazing the difference. Where we live, you get further north, the differences are even bigger. And of course, inside the Arctic Circle or Antarctic Circle, 24 hours of daylight in the summer, and certain days in the summer, and 24 hours of darkness certain days in the winter. Okay? So yeah, those are big, major factors. Now, the tilt of the Earth's rotation axis, that determines our seasons. That also is a big determiner of climate. The equatorial regions receive more solar. Okay, that's the same thing they're saying here. Intensity of the solar radiation. Intensity changes on a yearly basis, but not very much. The number of daylight hours varies annually. Now, this is talking about, okay, this is a poorly put together slide. The equatorial regions receive more solar radiation. The other regions, that should be another bullet here, the intensity changes on a yearly basis, and the number of daylight hours varies annually. These two are not true for equatorial regions. There's very little intensity change on a yearly basis and very little number of daylight hours varying annually. This is for the non-equatorial regions, the temperate and certainly the polar regions. Yeah, okay. So, these are the, well, they still haven't named the climate groups. We'll get to that. But these are the influences of them, the factors contributing to them, and sub-factors, I guess you would say. Now, this is very similar to what we saw in chapter 15. We talked a lot about these same issues then. And to a certain extent, I think in 16 as well. And here we are hitting it again. Yes?
I have a question about the midterm, the final midterm. What do you have to do to study for the final midterm?
You mean the final exam?
The final exam is everything.
Okay. And I'm glad you asked that now. By the way, since we are getting, this is an agricultural term, on the short rows now, meaning we're almost finished plowing the field, we're on the real short rows at the end. The last day of regular class will be Tuesday, 1 week from next Tuesday, right? You looked that up, right? Okay. On that day, I will be returning every test and every lab that you've turned in at that point. That means that's the last day to get these labs and tests in and completed. That's one week from Tuesday. So try to get them in sooner rather than later. Okay? Now, you might say, that's not answering my question. But yes, it sort of is. Because the major...
So when will you stop taking work?
I will take it anytime you turn it in, but I'm returning that. Once I've returned all those, I really can't get anything back. So you have to have everything into me no later than that Tuesday. I will take it that day when I'm returning other things, but I'd rather have it sooner so I can return it to you. Now, so for the final exam, we've covered chapters 14, 15, 16, 17, 18, 19, 20, 23, 24. 9 chapters. What I would suggest the best way to study for the final exam is you go through, I would say find what you consider the top 5 biggest issues, most important things in those chapters. Focus on them. Okay? Generally, they are going to be covered somehow on the test. So that's why when I return your test, you can study the test, make sure you understand why you may have missed, if you missed something on the test, or why this is the best answer. Okay, so that would be the next thing. Frankly, I find the summaries at the end of the chapters, of those 9 chapters, good thing to read and study those, I would say. And if you got that done, you're going to be in real good shape. Remember, the final exam is not multiple choice, but matching. And so all the answers will be there, and all the words or definitions will be there. You just have to match them up. So, yes.
I had questions on my lab 48. I don't know if it was motions of the sun, and then questions.
Okay, you didn't get them, or you lost them, or?
Well, no, it's just, this was all that was stated in my lab.
Okay. Well, see me right after class, and I'll try to go make a copy of that last part. In fact, let me look now. I don't think I had any extras because motions of the sun. Okay, the last page you have is page 374?
Yeah. Last page, yes, sir. That's the last page.
Okay. 375, 376, 377, 378. You're missing all those, right?
Yes, sir.
Okay. I don't have an extra copy, so I'll have to make some copies for you. And remind me, when you're starting the test, remind me I'll run down and make copies. Okay. All right. So, everybody got this one then? So let's look at climate and latitude. Okay? Now what we mean by the low latitudes, that means the small numbers. 0 to whatever, like 23.5 south to 23.5 north, 10 south to 10 north. Those are the low latitudes. Here we have high solar radiation because direct, the angle of distance is very small. Yearly variations, very small. That's what I was saying. The last part of the previous slide did not go with low latitude equatorial regions. Temperature uniformly high. Very little variation in temperature, and it's usually quite warm all year long. Because you have direct radiation, very little variation. Okay? Let's see if the slide goes along with that. Yeah, that's shown here. Direct radiation, these are the low latitudes, plus or minus. Now these are showing from, what is the Tropic of Capricorn? Okay. How far below it? Not quite.
13 degrees.
Yeah, more than that. 23.5 degrees, that's the angle, remember? Okay, you can't forget that stuff. Okay. So, between the tropics, Tropic of Capricorn in the south, Tropic of Cancer in the north, 23.5 degrees south to 23.5 degrees north. that band around there, basically 47-degree band around the equator, low latitudes. This is true for that. The middle latitudes, that's where we live, between the tropics and the Arctic. Arctic Circle up here, tropics down here, Tropics of Capricorn here, Antarctic Circle down there. These are the middle latitudes. Higher solar radiation during one part of the year, whatever your summer is, lower during the other part when you're winter. Why is that? Because of the tilt of the Earth. When you're tilting toward the sun, you get more direct radiation. When you're tilted away from the sun, less direct radiation. Okay? So higher solar radiation during one part. Overall temperatures are lower than they are around the tropics, okay? But greater variation than the lower latitudes, okay? There are times of the year when we will be warmer than Hawaii would be. In fact, a lot of time in the summer, we're warmer than Hawaii is.
Wait, what?
Say again?
What? You said we warmer than Hawaii?
In the summertime. Quite often we will be. Not always, but quite often. Because, well, number one, Hawaii's an island surrounded by the ocean. That sort of acts like a natural air conditioner. Okay? But in the wintertime, there's still that same temperature, and we're way, way colder.
Okay. That breeze coming off.
Yeah.
The water, but they don't.
Yeah. Actually, my nephew lived in Hawaii. He was stationed on a ship there. And he was there for 2 or 3 years, and it seemed like I heard him say they didn't have air conditioning. They just had to open their windows and let that sea breeze blow through, and it was usually comfortable.
Yeah, I would have stayed over there about a week.
Yeah. Okay, so great variation, much greater in the middle latitudes than the lower. At the high latitudes, this is 66.5 degrees north and up, 66.5 degrees south and down. There you have maximum amount of radiation during one part of the year and basically none in the other part, or very, very little. When you're tilted away from toward the sun, maximum radiation then. When you're tilted away from the sun, like sun's here and you're here, zero solar radiation.
So is that radiation depleting the ozone also?
What's that?
Is that radiation depleting the ozone also?
Yeah, the ozone probably is very different around the poles than it is around the other parts. I can't say exactly how it is, but it would seem like it'd have to be very, very different. But on the other hand, your magnetic fields are greater near the poles, and that may help the ozone some too. So I can't really answer that. It would be a great paper topic. Paper topic. Paper topic.
Paper topic.
All right. Overall temperatures are the lowest, but also with the widest variation. I mean, you can easily have minus 40 degrees, but you can just about as easily have minus 70 degrees there, and very low temperatures, but still huge variations. Okay? There are teams that have camps in Antarctica. You don't want to be there in the wintertime. Some people do overwinter there, but you really can't do much but stay inside. So you better have experiments you can do inside, because there's not much you can do outside there. Same thing in the Arctic Circle. In the summertime, it's bearable maybe, but in the wintertime, it's brutal. Totally brutal. And you can't see anything anyway because it's totally dark in the coldest and darkest part of the year. Everybody got that?
Yes.
Okay. So let's look at some climate zones. We're talking about major climate groups. Let's look at the climate zones. Okay? Defined in terms of yearly temperature averages. And again, same one we talked about before, they just got them in different order. The tropical climate zone near the equator receives the most solar radiation, hot. Okay? Now, before they said temperate next, but now we're saying polar next. These are the extremes. Polar climate zone, the least solar radiation any time of the year, and sometimes of the year none whatsoever, cold to colder. To coldest. I mean, it never gets warm there. Constant daylight part of the summer, constant darkness part of the winter in the polar zones. In the temperate climate zone, intermediate between the other two. Okay? We have more radiation in one part of the year, less in the other. Not as much ever as they do in the equator, but not nearly the variation they have in the polar regions. Okay? Now, this slide, this bullet seems like it belongs on a different slide. Rainfall patterns shift seasonally. Yes.
Why does it have a check mark next to it?
I do not know. I think it's checked because it's out of place. I mean, I don't know. I can't figure out why they put it there in the first place.
Is that a test question?
Yep.
That might be
Okay. That might be it. Okay. Okay. Now, these are the climate zones. Notice they didn't make them as stark as just the tropics and the Antarctic and Arctic circles, because it varies. Okay. Here they're inside. Here they're basically a little bit outside. Okay. And down here in the Antarctic, you have very polar, well above the Antarctic circle, and up here, yeah, you have some too, but some that are almost temperate inside the Arctic circle. Okay, so it varies a little bit, but basically it's showing the same thing we were talking about before. Tropical, temperate, polar. Okay. Now, since they have the rainfall patterns and people are still writing, let me tell you a little bit. We do have some shift, but we're really, really, really lucky. I mean, we have the Gulf of Mexico here. That keeps this moisture just about year-round, okay? Over here, over Mexico, it's just about dry year-round, okay? And but other areas. But some parts of the world, many parts of the world, they go by monsoons.
Go by what now?
Monsoons. They have rainy periods and dry periods. A lot of the equatorial region, that's how we measure. They measure it. India talks about the dry weather and the wet weather. They don't talk about summer, winter, fall, spring, dry season, wet season. I have a friend who's a missionary in Cameroon, which is right around here, and that's what they talk about, the dry season and the wet season. That's what they deal. Not summer and winter. They're always warm. What they deal with is when they're wet and when they're dry. So I think that's what they're talking about here, but they sure didn't explain it very well. Okay? Everybody caught up now?
Yes, sir.
Okay. Now, this to me is one almost ridiculous slide. There is no place where a zone is going to be straight lines like this and straight lines like this and break like that. It just doesn't happen. This is just some artist's rendition. This is the rainfall pattern shift seasonally. I guess that's the only thing to do it. Very wet generally in the tropics, but not uniformly in the tropics. Okay? Northern South America wetter than mid-South America. Okay? But this is the bizarre part. Wet in the middle, dry on either side of the wet, and then wet on the extremes. And look at lucky us. Almost our entire country is fairly wet. Yeah, we just lucked out here big time. And if we turn the globe a little bit, Europe lucked out pretty much big time too. Turn the globe a little more, Africa, Northern Africa, Sahara. You know, Salil, they call it. It's the Sahara region. Huge expanse of desert, okay? Turn it a little bit this way, and you have parts of China, Mongolia, and those places. The Gobi Desert, I believe it is. Just, yeah.
Mojave Desert.
Second?
You said the Mojave Desert?
Mojave is in California. Gobi is in, I think that's the name of it in Mongolia, I believe it is. Okay. So yeah, you have in for Mexico and some of Central America. Now the Yucatan Peninsula is wet, so this varies. That's what I mean vary. This is not really a pattern. This is just sort of an overall average. You don't have sharp lines like this. In fact, an upcoming slide is going to say there are no sharp borders. It's all flexible. Okay, and then what they didn't show, these are the polar areas, so those are icy. Okay, it doesn't matter whether they're wet or dry, it's always ice. Okay, so let's look at some of the regional climate influence. Did everybody finish the last slide? Okay. 4 major factors, 2 on this slide, 2 on the next one. Regional climate influences. One is altitude. Now, frankly, I find altitude and mountains, they're almost the same thing, but not quite. Altitude, higher altitude, air radiates more energy back into space because you have less atmosphere over it. The atmosphere acts like a insulator, like a blanket, and since at high altitudes you have less blanket, it gets colder. You re-radiate
So what
back
I mean
into
when you
space.
say the ass thin?
The air thins, exactly. That's it, exactly.
So, so the universe needs blank. Quilt.
Yeah. Down in the equator, you're covered with a quilt, and up on the top of the mountain, you've got a sheet. That's about all. Okay. Now, mountains. Isn't that got to do with altitude? Yeah, it's got something to do. The cooler air is at higher altitudes, from what we just said, but there are other climate influences there. Always in the mountains, okay, especially if you have prevailing winds, and most places we do. In the temperate area, like where we live, they're prevailing westerlies. The prevailing wind is usually from the west. So coming off the Pacific Ocean, you have a ridge of mountains just right there, just inside the border, just inside the coast. And that ridge of mountains keeps the moisture from going on the backside of the mountain. When I was in the Navy, my home port for most of that time was Concord, California. Okay? And on San Francisco's side, it was pretty moist. In fact, it was green most of the year. It was warm most of the year, okay? And then, to get to Concord, you actually drove through a mountain. It was a tunnel that you drove through. It was green on this side, you drove through the tunnel, on the other side it was brown. Because the mountain got the moisture coming off the Pacific, and on the other side there wasn't. So that's why they say the upwind slopes receive more precipitation, and the downwind slopes less. Now in the temperate region, that's the western slopes receive more precipitation, and the eastern slopes less. What's one of the wettest cities in the U.S.? Seattle, Washington. And yet you go across the mountains into Pullman and some of those other areas of Washington, eastern Washington, it's pretty dry. So you have wet, mountains, dry, okay? The upwind slopes receive more precipitation. That catches the precipitation, it runs back down. On the downwind slopes, generally less. One of my favorite spots that I discovered in our country was in the western side of the mountains in Marin County or somewhere there north of San Francisco. It's an area called Muir Woods. It has giant sequoia trees there. I mean, just massive. And you drive down in there and you almost feel like you're in not a tropical rainforest, but a temperate rainforest. It's damp, it's cool, all the time. Because the mountains have caught the moisture, those trees have just sucked it up. They are huge. They actually, when you're driving down into it, you see the top of the trees, and you drive further down, you see lower in the trees. The trees cut through, they're so tall, through several different areas, it's just amazing. So the mountains, in addition to altitude, they also change moisture patterns as well. Okay, number 3, large bodies of water. Thank you, Gulf of Mexico. If we didn't have it, we would probably be a desert because the winds coming off the Pacific, they would have no moisture by the time they got to us. But we have the Gulf of Mexico, which is one warm bathtub that's just sending up moisture constantly to us. High specific heat of water moderates the temperature changes. Yes?
What would happen if the Gulf of Mexico was cooler? If it was like cool oceans?
Yeah. Don't know. Being as far south it is, mostly below the Tropic of Cancer, so it hardly could be cool. But if it was, that would be like Hudson Bay. Hudson Bay is cold, I can guarantee you that. So they don't get as much moisture pumped off of there. They do get some, but not as much. Lake Erie, well, the Great Lakes, any of the Great Lakes, they have Rochester, New York, Buffalo, New York. They have more snow than some other parts of New York. Why? Because they're close to the Great Lakes, and they call that lake effect snow. The moisture coming off the lake falls back down as snow just once it leaves the lake. And that's partly because of this high specific heat of water. Moderates the temperature changes. Why do people go to the beach in the summertime? Huh? That's what?
To get tan.
To get tans, okay, that's okay. Unfortunately, that's probably true. But when we have been to the beach in the summer, Karen's family used to go about once every 2 or 3 summers. They would plan a big trip to the beach. And you drive from Birmingham, they were from Huntsville, but driving from Birmingham to Montgomery, you see the temperatures slowly go up and go on down. But once you get almost to the beach, $1 at 10 o'clock.
And that second shift.
Yeah.
That second shift.
That's what it is.
All right, good deal. Thank you.
One more, they'll do it.
All right. Now, but once you got to Gulf Shores, the temperature dropped. Why? Because the high specific heat of the water moderated the temperature changes. And in the morning, in the daytime, it would be cooler on the beach than it would be inland. But at night, it would be warmer on the beach than it would be inland. Because the soil temperature changes more rapidly. It has lower specific heat than the water did. In fact, that influences a lot of what's happening.
Warmer at night.
Yeah, warmer at night than the land would be. Not than it is during the day. Okay, sorry. Okay. Warmer than the land was at night. Okay. In fact, that contributes to, back in the sailing days, okay, in fact, it still happens, but we don't take advantage of it as much. In the daytime, the water temperature is cooler than the land, so basically the land, the heat rises and the breeze comes off the ocean going in. Now, I used to like to not get up super early, but fairly early in the morning and walk the beach. And then there was hardly any wind at all. Okay? Huh? Yeah, I didn't have that, but yeah. But then in the nighttime, the water temperature was warmer than the land, and the wind would reverse, and it would blow the other way. And that's why in the old days, this was before my time, the ships would go out at night because the wind was blowing them out, and then they come in the morning in the day because the wind was coming in. So why fight it? They did. So the fishing boats and other things would go out at night and come back in the day. And people say, oh, the fish must bite better at night. No, it's just easier sailing to go out at night and come back in the day. Okay, so large bodies of water, because of the high specific heat of water, moderates the temperature changes. And then the ocean currents. These things we don't understand so much, but they surely are there. They can bring water nearby that has a very different temperature from land. In fact, we have a fair amount of that. And this is what we're going to talk about more in the next chapter too. We have, thank you very much, The Gulf Stream. The Gulf Stream keeps all of our eastern seaboard pretty warm. Okay? New Jersey, Atlantic City, New Jersey, Long Island, New York. Those all have really nice beaches. People enjoy the summers out there. In the wintertime, they don't do much, but actually, they're not so bad. They never freeze up in the wintertime. Our whole eastern seaboard, even way up north. Maine may come close to freezing. Well, the reason for that, there's these laboratory currents that come down here, freezes things in Canada. I mean, they have it pretty rough there, but most of the U.S. doesn't get frozen. The Gulf Stream keeps it warm. Whereas on the West Coast, even in San Diego, even in summertime, people sometimes wear wetsuits when they're on the beach just because the water is so cold. Because they have this California current that's cool. That keeps the water cooler than New Jersey would be here. Believe it or not. Long Island, Cape Cod, Massachusetts. All those are really nice in the summertime, whereas San Diego is still, the water itself. The temperature is nice in San Diego, but the water temperature is quite cool. But, fortunately for Alaska, there's also the North Pacific current that is warmer than the waters typically would be up here, so it keeps Vancouver, Canada pretty pleasant, okay? And most of the Alaskan areas here stays moderately well. It's cold up there, but not as frigidly cold as St. Lawrence would be over here. And that's way further north. So yeah, the currents, ocean currents, can bring water that's much warmer into an area that should be colder, or much cooler in an area that should be warmer. So lots of sort of weird things. We'll talk more about currents in the next chapter. Okay? Now, how do we describe climates? Well, remember that the diagram I showed you that said was almost ridiculous? Here's why. Problem. There are no sharp boundaries. Okay? You can't say, oh, on this side it's temperate, on that side it's tropical, or yes.
What do you mean by sharp boundaries?
Okay. Here's, if you'll excuse me, I know y'all are writing. That's ridiculous. It's not that you're very wet right there and very dry right there. Okay. Yeah, it just doesn't happen that way. It's no sharp boundaries. It's always gradual.
That's a pretty picture.
It's a pretty picture, and that's about all it is. I mean, no, it shows general things. Okay, so let's get back. There are no sharp boundaries. It's sort of like, can you tell when you went from Georgia to Alabama? Well, if you crossed to Chattahoochee, you knew you did, but otherwise, if there wasn't a sign there, you wouldn't know it. Yeah, I mean, their boundaries are sort of artificial, and the temperature, that's why 23.5 degrees north, it's not that suddenly when you get 23.6 degrees north, you're much colder. No, no sharp boundaries. Everything is gradual, okay? But, on this other hand, no two places have exactly the same climate. Now, they're called the Mediterranean climate. That's sort of similar throughout the Mediterranean, but not the same. And they say San Francisco Bay Area is similar to a Mediterranean climate, but it still has some pretty big differences, okay? So there's no two places have exactly the same. One may have a little more rainfall, other a little more, yeah, sorry.
I had a partner stay in Nashville, and one time he came and got me about 8 in the morning from the house. It was the summer, so it wasn't summer, it was probably fall. So it was pretty warm. I left out my door wearing shorts and stuff at the time. Man, when I got that car in Nashville, I needed a coat.
Yeah. Right.
It was drastically different.
Yeah, right.
Yeah.
In that time of year, and like I said, there wouldn't have been that big a difference in the summer, but in the fall, yes, it can be. Just like you were saying, snowing in Colorado right now. In the summer in Colorado, they can sometimes be almost as warm, and maybe even on certain days warmer than we are here. Just depends on what's happening. So there are no sharp boundaries, and no two places have exactly the same climate. A description of the North American climate zone follows, and this is a pretty interesting graph. I'll wait a minute. Build you up to it. You through? Everybody through? Okay. Let's get the picture here too. All right. Marine climates near the ocean, and this is right here. It's this blue. Okay? Not that blue, this blue. That is a marine climate. That's the Yucatan Peninsula of Mexico. Plenty is near the ocean, in fact surrounded on three sides by ocean, influenced by air masses from the ocean. They are wet, they are pleasant, beautiful beaches there. They get hit by hurricanes periodically, but that's a nice place to go. Cozumel, I think, is there. I've never been there. But, now, then you have, okay, I'm sorry. Several of these are marine, that's just one. Continental climate are far from ocean. This is big classifications now. So that would be like in here. There is, that's this one, semi-arid. Semi-arid is here. Some of these colors are awfully close together. That's continental. You don't get much moisture. It's semi-arid. Yes?
Is that why there's so many deserts in Washington?
Yes, exactly. That kind of thing. Okay? Far from the ocean, you just don't have the influence of that. Influenced mostly by air masses from large land areas, like coming off of Canada or coming up to Mexico or coming east or west here. And largely because you have mountain ranges here that block moisture from getting across here. Okay? Other classifications. Arid. That means much drier. Where is there arid over here? I see semi-arid here. I don't see one that's just called arid. But I know there's one on here called desert. I just can't see it. There it is. This is the desert. This would be arid. Okay? Yes?
Canada seems to be practically surrounded by water. Why is it mostly marine climate?
Okay. That is an excellent question. I was just going to point this out. Look at this one, folks. This, to me, is remarkable. The Yucatan Peninsula here is surrounded by water on the west, the south, and the east. Almost completely surrounded by water, and yet its classification is a desert. That is a desert. How? Why? Something weird there, okay? And even on that side it is. Here is the Mojave Desert in here, and there's a lot bigger. Poor old Mexico, lots of its center. I think Mexico City is a very dry area most of the time, but they do occasionally get tropical storms coming in.
They're sinking.
What's that?
Mexico City is sinking.
Sinking? Is that right? Wow.
Yeah, they've used water.
Oh yeah, they've been pumping out the water out of the groundwater.
So
it's subsiding is what they call that.
And it's like so heavily populated.
Right, and they just keep pumping water out, and it doesn't enough to recharge. And guess what? Once that collapses, we'll talk about this in the next chapter. There is no rebound. You can't pump that back up.
Why are they pumping the water?
To drink. I mean, they've got a huge population in Mexico City. It's probably one of the largest cities in the world. I don't know where it ranks.
It's up there with India, what's the name of that one?
Calcutta.
It's one of the top 5 most populated for the area.
Right.
They just keep cramming more and more people in there.
Yeah, people coming from the countryside who's pretty poor, hoping they can make more money.
And it's making everything, it's kind of strange.
Okay. Semi-arid, that would be this one. That's the one I mentioned here. That's the semi-arid. The humid, that's where we live. Let's see if I can find it. Humid subtropical, that's where we live, right there. Thank you, Gulf of Mexico. You keep pumping the water up to us, and we'll use it. And yet, We're one of the wettest areas in the country, and yet we are beginning to have water issues. For a while, Georgia, Florida, and Alabama were almost at war with each other over the Chattahoochee River and who's using all the water and they shouldn't use it all. Yeah, really, I think the governor's worked out some deal, but we shouldn't be. But again, you get population densities in some areas that can't support it. Even Miami, they're using so much water from the Everglades. The Everglades are getting dry. That's a huge, that's not a good thing to happen. The California, the biggest agricultural area in the country, they are irrigating like crazy because they are dry, okay? They irrigate like crazy. They are going to be subsiding soon, and they're also going to be salting up. West Texas, okay? They pump so much water out, they're sinking. Not smart moves by anybody here, okay?
Okay, Mr. Platt.
Yes.
Since you said none of the water is smart, then why don't we just use soap water?
Okay, because it's salty. Okay.
We're gonna ruin salt.
Okay, yeah, but it's more expensive. But that's exactly what Israel does. Israel desalinates water, and it's expensive, but they've got plenty of water.
So the government gonna start selling us water for
What's that?
they're gonna start selling us water.
Yeah.
They're gonna start privatizing.
Yeah. Actually, some people have predicted some of the next wars, maybe not the immediate ones, will be water wars.
Right.
People
Privatizing the water.
Yeah. And in fact, that's one thing I heard somebody saying in the current mayoral election. Some people are really hacked off that the Birmingham Water Works no longer belongs to Birmingham. It's a private entity. And some people are very upset with that.
That's why I got it.
So let's look in general here. Up here in the northern part of Canada and some of North Alaska, you're in the polar regions. Okay? That's a climate issue. Here's I was mentioning the Hudson Bay. This is Hudson Bay here. I'm not sure they get lots of lake effect water off of that. They get some, I'm sure, but not really to an extent, because you see you have to have heat to evaporate the water to give you more precipitation. We have it in the Gulf of Mexico. They don't have it up there. Okay. Humid, continental, but not, I can't read that, not Arctic. I don't know what that is. That's it. Is that what it says? Okay. Okay, that's this band here. Fair amount of moisture, but it's still fairly cold. Humid, continental, mid-latitudes, is that what it says? That's this band here. Second?
It's in the book.
Oh.
It's in the book. Okay. It's on page 593. And the table is over there too with a little more detail. And by the way, I guess I skipped over a few figures here. Let's hit them. Going back, page 590, wide variety of plant life can grow in tropical climates. In fact, some of the tropical rainforests probably have, and that's a fairly small area, probably have close to half of the different population species existent on the planet. They have plants, they have animals, they have bacteria. In fact, there's probably medicines from plants and maybe animals too that could be harvested there, but we don't know enough about it to get there, and it's very expensive and difficult to do. But they probably have some plants that produce saps or things that would be great boons to medicine. But we don't even have a clue about what most of is going on there. Figure 2326, the polar climates, very cold there, occur at high elevations. I think these may be reindeer or something like that live up there. How they live on that little stuff to eat, but they do. Temperature climate of deciduous forest responds to seasonal changes, for instance, the autumnal show of color. Now we have decent color here in the fall, But boy, go up to New England and some of those areas, it's spectacular because they have more deciduous trees and fewer conifers, evergreens. And then the ridiculous little globe there. Okay, and that leads us up to this one. So let's read through some of this. Polar was the white one. Then humid, continental, subarctic. That was the band up here. Okay. And notice, is this Brunswick Island maybe? I can't remember for sure. Nova Scotia is somewhere there all the way. Okay. Humid, continental, mid-latitudes. That's what I thought it said. That's this band here. And most of the Great Lakes are in that. Northern New York, most of New England, up in here. So that's, again, humid, but more continental, mid-latitudes. Humid, continental, lower latitudes, that's this here. Boy, that is our grain belt. That is our agricultural belt. Just tremendous, good soil, pretty good conditions for growing crops. You don't really need to irrigate that much. I bet you they still do. And then humid, subtropical, that's us. We've got the heat, the subtropical, we've got the moisture, Gulf of Mexico, Atlantic. Really good stuff. Okay? Tropical wet, that's this right here. Tropical with seasonal wet dry, almost monsoonal. That's this green down here. Okay? The wet seasons and the dry seasons. Okay? And semi-arid, that's this right in here. Gulf of Mexico, that's not arid, it's semi-arid. Anything that's not under the influence of the Gulf of Mexico, but blocked by the mountains here, that's where you get that. Okay? Desert, that's this area here, poor Mexico and some of the southwest U.S. Marine, that's this part here. Okay? This is tropical wet here. I said it backwards. This is marine here. This is temperate marine. There's Seattle, right in there. So yeah, and Vancouver, all that was pretty wet. Okay? And those California currents that cut up like this, that's what keeps it nice and wet. Mediterranean, that was this here, the Bay Area and San Francisco Bay Area and a lot of the agricultural valleys there, Mediterranean. And then the highlands are here, and you have some here and here. Those are rocky mountains. I mean, fairly inhospitable there too. Almost uninhabitable. Okay. Local climates. I'm guessing we're not going to have time probably to do that. So let's just plan to start there next time. Okay? And then we'll do climate change. And we'll finish the chapter probably within the first hour. Okay, now I say next time. What is that going to be? We start next time going to the planetarium. Now, I haven't heard from him how long he's going to keep us. So let's say we're there from 2, not all day. He runs out of steam before that. So at max, it's going to be 2 to 4. I don't think it'll be that long. And so at 4 o'clock, we'll come back here. We should be here by 4:45. We'll have another good hour here. If you want to come, if you're riding with me, I'll be coming back. So you're welcome to come on up here. If you are wanting to go home, that's up to you. I'll record everything just like I do every day, so you'll be able to catch. So when we get back here, we will do the last of this chapter. Okay?
Be here at 1:15 like normal.
Yeah, be here at 1:15. For some of you, not like normal, because we'll be leaving at 1:15. Okay? So be here or aloha. Okay. So we'll go to the planetarium, come back, finish the chapter. Okay? If there's time, we may go on and start chapter 24. It just depends on how much time we have back here and how far it is to do. Also, around in there, sometime I will be trying to get in touch with Jerry Tracy to see when we can go to the Channel 13 weather. Okay? If we can't do it either Thursday or Tuesday, we're not going to go. But we'll see if we can do it one of those 2 days. And I'll let you know on Tuesday. Okay. What's that? Okay. I need to make sure we don't exceed 11. How many of you want to ride on the van? 1, 2, 3, 4, 5. That easily is less than 11. Anyone else up to 11 can ride in the van, and the rest will have to ride with somebody else or something. Huh? You're going to be driving? Oh. You want to ride on the van? Okay.
Yeah.
Okay.
I mentioned that Tuesday.
Yeah, that's what I thought, but I didn't see your hand go up, so I thought you had changed your mind. Okay, so I think we'll be able to fit as many who want to come, but I'll have to check with them and see, but I believe the limit is, even though it's called a 15-passenger van, our insurance only covers 12, and that includes the driver. Okay, yeah.
Everybody wasn't here when you said it count for a grade.
Oh, okay. In case you didn't hear this, okay. So far, okay, in total, hopefully we'll be not doing 9 chapters. Okay? We've had a lab with every one of them so far, except this one. This chapter will be the trip to the weather center. The planetarium was actually an extra lab. Okay? And we'll do a lab for chapter 24. I think there will be time, so we'll do that. Okay? So basically that's going to give us 8 regular labs. Okay? Now, if you go to the planetarium Tuesday, that's basically a bonus lab. You get 25 points just for going. No report, nothing. You just get 25 points for going. If we go to the weather center, another bonus, 25. Okay. So basically what I do, I take your top 7 scores and average them. That's your lab average. Okay, I drop the lowest. We have 9 regular labs. Drop the lowest. 8 regular labs. Drop the lowest. That gives you 7. And then if you go to the planetarium or the weather center, that's another 25. So that means you get to effectively drop either 2 or 3. Because everybody gets to drop 1. If you go to one of the things, you get to drop 2. If you go to 2 of the things, both of the other things, you get to drop 3 of your lowest scores. If it helps. Yeah. I'm sorry?
We can drop the moon.
Don't drop the moon that fell off the earth. No. Okay. All right. But no, if you think about the moon, we did most of it in class. There's just 3 questions of your observation that can't cost you that much. Okay? In fact, I think it's fewer than 3 points. Yeah.
Okay, so I'm just looking at Kepler's law.
Sufficient?
Yeah, I think so. Yeah. Say again?
I'm looking at the Kepler's law.
I can't hear what you're looking at.
Looking at the campus, what?
Kepler's law. And it said, so originally Kepler's law was created because it was doubted about Mars. What?
Kepler's law.
Kepler's laws. Okay, right.
Because it said something about, it said Mars appears to walk backwards across the night sky. What does that mean?
Okay. If you look at the sun comes up in the east and goes across like this. Okay. And every day right now the sun's coming up a little bit later and got quite as high and done. Okay. So it's really regular. The moon's pretty regular. The stars are very regular in their pattern. Mars, however, one day it'll be here and then but then sometime or another it stops and goes like this. And then it stops and goes back like this. It kind of wanders from day to day or week to week. That's why it was called the planet, because it kind of wandered. Okay? And Kepler was trying to figure out mathematically what was going on there.
What was going on with Mars? Not with
Well, all the planets, but Mars was the most obvious one. It was the one closest to us, but farther out from. I mean, Venus is closer, but it had more of a regular pattern. Mars being further out, and there was a figure in the book that showed why that happened, and that very thing I just said was sort of illustrated there. But yeah, okay, good deal. Okay, ready for the test? Okay, I'm going to end the